Ahoy, me hearties!
All hands on deck.
4 minutes. We're going to get started in 3 minutes now.
Ahoy, me hearties! Send 'em to Davy Jones' locker. All hands on deck.
We're going to get started in 2 minutes. All right, 1 minute. Okay. Cool. All right. Let's see. We got the green light on the live stream. We're good? Ready to go? Oh, me eye patch. There you go. There. Oh my God. Ahoy, mateys! All right, all right. I like the energy. I'm going to have a little hard time advancing the next slide with one eye and one hook. There, okay. Welcome, everybody. Welcome to this the second Perf Matters event at SF HTML5. If you're active on social media, definitely post with the hashtags Perf Matters or Perf Like a Pirate or SF805. We'll find you. We have some great prizes tonight, including wine, PS4s, Chromebooks, and all of that. So we have some great stuff. So definitely show us your tattoos, show us your hats, show us your Perf Matters gang signs. Hey, wanted to quickly give a great round of applause for our musicians. It's not just Rocky tonight. He's actually accompanied by Justin Ward, who I met in front of Macy's. He was playing so well in front of Macy's. I was like, you have to come over and play with Rocky, and there they were. So that's really great. So another round of applause for Google for putting up this great event. All of the great food, the the hosting us, the food, the drinks, and everything. So couldn't have done this without that. And also a quick shout out to the the team behind the scenes. So all the people that have been working behind the scenes, the audio video team, all of those guys have been here all day long, including last night. Just a great effort to get this live stream. And for those of you on the live stream, welcome. We're trying to always live stream these events, and we usually have a couple hundred people on the live stream. If you have any questions, we're trying to moderate on Twitter, so you can post some questions there for the final Q&A tonight. Okay, so at Google, we in the developer relations team that we're part of, and a lot of us are here today, we spend a lot of time building great training and videos and so on, things like this, but also training courses that we build in partnership with Udacity. And so I'd like you to all check out some of the great courses we've recently launched, including a very relevant one is about web performance with Ilya, our second speaker for tonight. So definitely check that out, udacity.com/Google will get you all of our courses. Also wanted to thank a couple of the sponsors before we get started. So first sponsor, one of the founding sponsors of the group is Kazing. They built an enterprise WebSocket gateway, basically a WebSocket server that is very high performance. They are usually hiring, so definitely talk to Vanessa and some of the other Kazingers that are here. Also wanted to thank Adobe, Microsoft, and Modern IE, and ClearSlide. And ClearSlide just joined us as a sponsor, and Fabio is here to talk a little bit more about them. Thank you, Fabio.
Thank you. Hi, guys. Very nice to be here representing ClearSlide. I'm part of the software engineer team at ClearSlide. I'm here to say just a couple of things. First, thank you to the SF HTML5 meetup for having us. Very honored to support these kind of sessions. Nice. Let me just briefly go through, browse through ClearSlide. We are a sales engagement platform. What that means is that we build tools and software to make sales reps, one, more efficient, two, we help them sell more deals faster, and be more productive, basically. If you go to the website, clearslide.com, I'm sure you'll find one of our more challenging features, which is our live pitch module. Basically, that allows users to upload content, such as media, videos, audio, images, and present and share that to many viewers online in a synchronized way and live, right? For the client-side development side of things, it's very exciting because we really use intensively things like HTML5, JavaScript. We rely on frameworks like Angular, which is pretty awesome. So yeah, if you're interested, one, you can go to the website. I'm sure we have very cool things there. Or stop me, grab me, I'll be sitting over there, and I'll answer any questions that you might have. Thank you.
Thank you, Fabio. I have to say, it's really disorienting walking around with this eye patch. Or maybe it's the beer. That's right, maybe I'll try that. Hey, one of the great conferences, local grassroots conference, HTML5 DevConf. This will be, I think, the 7th or 8th time that it's happening. It will be on the week of October 20th. They have 2 days of conference at Moscone. Tickets are incredibly reasonably priced. There's also training. Check it out. We actually have several tickets to the conference as raffle prizes tonight. But the tickets aren't super expensive. You should definitely check that out if you haven't gone. All right, next up, we have some words from Twitter. John. Thanks, John.
Hi, guys. My name's John. I'm with the developer advocacy team at Twitter. Definitely happy to be here. It's one of the best meetups around, one of the best crowds around, but don't tell the other meetups I said that. Just want to announce a couple of things. We just recently relaunched dev.twitter.com last week. Admittedly, our previous website was pretty awful and people couldn't find things on there very easily. We reorganized everything and the API documentation is much more organized, so take a look at that. We also relaunched our developer community forum, and all of our developer advocates, some of our product engineers are always on that forum every day, so if you need help with any APIs or integration for your websites, jump on there and ask some questions. We also, the Twitter Flight DevCon, if you're a mobile developer, that has just opened for a public registration last week, so if you're interested in mobile development and what Twitter's doing in the mobile development circle, register for that and apply there. And lastly, we brought a Raspberry Pi for the raffle, so stick around till the end, and maybe you guys can win that. Thanks.
All right. Thank you. Thank you. Great.
They want the sponsors up here. Sorry? They want us to stand up here. Hi, guys. Are you glad to be here on a Friday? Cool. So I'm from Leap Motion. Hi, guys. Have a booth over there. We're showcasing our V2 tracking, which is using 27 or 26 points on your hand. And we're also showing our top-down tracking, which is for any HMD. And so you can make your applications in VR, WebGL, AR, any kind of application in which you want to use JavaScript. We love it. Please. Developer.leapmotion.com. Go to it. Love it. There's plenty of examples there. You can build any JS program based on just one line of code. Go for it. Thanks, guys. Boom.
26 fingers. All right. Next on deck, Matrix. Justin.
Hi. I was told to stand over here. Hi, guys. Justin Harless with Matrix Resources. I run the Bay Area here for Matrix, as well as the Seattle market. Matrix is a technical staffing firm. What does that mean? It means we help everyone here either find roles, or as hiring managers, we help them fill roles. The market right now, as you guys know, is probably the hottest say it's ever going to get, but it's hot, and there's a lot of good opportunity out there. We would love to talk to you guys either about opportunities down the road, or just network in general. We have 8 senior recruiters here in San Francisco. The clients that we're working with are definitely on the cutting edge from a technology perspective. A lot of front end, back end, full stack engineering roles. At least half of what we're working on right now is development related. So we have a booth outside. Again, we'd love to connect with you and just stay in touch. Everyone that has an accountant and an attorney in this space, it would be wise to have a good recruiter as well. So thank you guys very much. And we do offer $500 referral bonuses for anyone that can refer us talent. Thank you very much.
Thank you, Justin. All right, and Boom.
What's going on, everyone? My name's Todd. I'm part of the client integration team with Moboom. For you guys that don't know who Moboom is, we're adaptive and responsive web platform. We try to make it really easy for you guys, whether being designers or developers, getting on to our platform and building great-looking sites. We render on 5,000 different devices, going from desktop all the way down to BlackBerry devices. We have a full... BlackBerry? Yeah. We're going to throw that out there. Yeah, and then we allow developers like yourselves to go in and build any customized widgets. So whether it be a carousel or anything like that, you guys can get in there and start building your own widgets on the platform. We have a booth right outside, so if you guys have any questions, just let me know. Thanks, guys.
Great, thank you. Don.
Hello. All right, guys, stand in front of the podium. I don't know how many times I'm going to be able to stand in front of a pirate mass. So my name's Don Olmsted. You might remember me from the WebGL meetup in January, talking about what Sony does out here. So we are doing plenty of web dev, both front end and back end work, specifically on the PS4. So this is one of the rare opportunities you could have to be doing web dev on a console. We primarily work in WebGL in our custom stack. We're also investigating technologies such as Polymer. So we really work on some cutting edge stuff, and we'd love to talk to you. We have a booth outside, and Peter stole my thunder, but we are giving away a PS4 tonight, so stick around. All right, thank you guys.
Thank you, Don. Sorry for stealing that thunder. Yeah, sorry. Actually, so do not worry if you don't have a raffle ticket. Look on your badge, and your badge is your raffle ticket. See, there's no Googlers. You need to get an actual badge. You can still get it at the break. So your badge is your raffle ticket. We will be drawing some great prizes from books, wine, PS4, Chromebooks, and so on. Finally, Chrome Dev Summit is back. How many of you went to Chrome Dev Summit last year? Okay, some of you. Cool. So we're doing it again. It's going to be on November 19th and 20th. It's a Wednesday and Thursday. And we'll be raffling off 3 tickets, but public registration is going to open up on Tuesday at 9 a.m. Pacific time. So definitely go to the website. It's g.co Chrome Dev Summit. Check it out. Come back there at 9 o'clock sharp. We're really gonna, this sold out in 41 seconds last year, just FYI. So get your tickets. Okay, all right, without further ado, let's mix this in here. Okay, so I'm gonna invite our first speaker up here. Colt really put this event on the map last year when he realized that it was actually happening on Talk Like a Pirate Day. So here we are. Colt, warm welcome for Colt. Thank you.
Once you get there?
No.
No? Well, you guys...
In the mic now. Testing. This happened last year too. Hello, everyone. Hello. Are we all properly boozed? Yes. Are we all properly boozed? Yes. My name is Colt McCandless, and I know I've gotten a lot of weird, confused emails and looks in the past couple of days about like, what is this Perf Like a Pirate thing? And so for those of you who don't know what it is, I want to give you a little bit of history. So last year we did this Perf Matters meetup on SFHTML5, and it just randomly happened to just weirdly land on Talk Like a Pirate Day. And so I said, you know, hey, how many times do you get a chance to be fired in your career? And so I'm gonna do the entire talk in pirate. So historically, though, this was a really weird anomaly because after that, that happened. For those of you on the live stream, like autocomplete. No one cares about my Twitter or my blog, the Colt McCandless Pirate, which I thought was great. But more importantly to me, like apparently this talk changed someone's life, right? Like 1 minute in, this is by far the best talk I've ever seen. Like I have no idea how to help this man any further. Like, first off, how do you top that, right? Like, this man's life was changed because of my crazy pirate talk, which is a little awkward for me tonight. I mean, here you all are, pirated, and our cast and our crew is pirated, and it's a little awkward for me to just come up here and start talking like a pirate, right? No. Okay. Keep that enthusiasm. So what we're gonna do tonight to make sure that everybody wants to talk like a pirate is we're gonna sing a little pirate song together. Yar. So I'm gonna hit start here. I wanna invite all the speakers, everybody. I guess I'm keeping the mic. Where do we go here? You go, I get this one?
All
right.
hands on deck.
Up, all right. So now everybody, if you want us to talk like a pirate tonight, we need to hear you sing. Louder than us. Watch the words we're gonna have here, okay? And make sure that you sing along. This is gonna be available for download afterwards, by the way. I wanna hear some ringtones on the streets of San Francisco. Yo ho ho, Perf matters to me. Yo ho ho, Perf matters to me. We profile, we think, we fix it, we test. Perf matters, me parties, yo ho. We never give up and never will rest. Drink up, me hearties, yo ho. Yo ho ho. Perf matters to me. Well, no, you got it. There's a break. There's a break. Be mobile or web, we all be one crew. Drink up, me hearties, yo ho. We're really bad eggs and strange is our brew. Drink up, me hearties, yo ho. Yo ho ho. Perf matters to me. You gotta wait, see, you got it that time. All right, ready? Here we go. When you're happy, slow, or your boss be mad, drink up, me hearties, yo ho. When your users be leaving and never be glad, drink up, me hearties, yo ho. Profile your app and fix it up right. Perf matters, me hearties, yo ho. Never a slow app without a good fight. Perf matters, me hearties, yo ho. Yo ho ho. Perf matters to me. Let me hear you. Yo ho ho. Perf matters to me. Louder. Yo ho ho. Perf matters to me. Keep going now. Yo ho ho. Perf matters to me. Here we go. Drink up, me hearties. Perf up, me hearties. Drink up, me hearties. Perf up, me hearties. Perf matters to me. Now get off me stage, you mountainous doubloons. Let's get to what you all came here for. I said I. Listen here, you rascals. I didn't come here to hear you bellow to your mothers. I said I. That's what we be hearing. My name be Captain Main Roach, and I'm here tonight to teach you how to keep your vessels running smooth and fast and straight and through the world of performance. I think I swallowed a bug. All right, just give me a second. Grog. Tonight we be here for one thing, lads and lasses. I be here to teach you how to properly plunder that battery booty. Yar? In order to understand that, we need to talk about your mobile ship. Yar, she be a good vessel out about your day, helping you haul your load, fight your battles, and upload pictures of various parts of your anatomy to the internet every day. It's, I'm on Snapchat, I see what goes on, and really most of you shouldn't be on it, except Peter, he's okay. He's a good-looking man over there. But everyone know that the crew be the life of your ship, aye? I said the crew be the battery of your ship, aye? That's right. But the fact is that as you be going about your day, plundering and pirating, your crew's gonna die. Yeah, it's true, it's true. The pirate's life is hard with, you know, scurvy and the scorn of the sea and checking your email 15 times a day. They just die. Yar, the Kraken. Yes, that's a different metaphor. We'll get to that one later. But I like where you're going. So the question be, the more you plunder, the more you do, the more your crew dies. And the more you need to get back to port to get somewhere to throw the dead ones overboard and get a nice live crew with a real pulse, right? Yar, many a time we all be cast to sea with our energy crew thrown, are we getting the metaphors? Our energy crew be thrown overboard trying to find a charge until we get back home. And the fine traders at Purdue Pirate University, go fighting Boilermakers, did a study of the top pirate ships out in the sea. And what they found was these cockroaches of captains had no care for how their crew was being slain. They were letting the entrails of their men just be slaughtered all over the floorboards where the gulls come and nest and feed upon their entrails. For the standard pirate activities of tossing birds and reporting the news, only 30% of their slain crew actually went to the pirate deeds that they be doing. The other 70% of their crew that they be slaying was done to things like checking whether there was an update, or figuring out whether or not they can upload user data, or downloading advertisements to display. And the truth is, these captains had no idea what was eating up all of their crew. It was as though there were a magical shark just hiding aboard on their deck, waiting to eat their crew when they weren't looking around. Land shark. Ship shark. Narwhal? Battery shark. I like the crew tonight. Yar! Yar! When we get this much feedback, it means the grog was good, aye? Aye. I'm seeing the back rows are not grogging enough. All right. The front's quiet down for a second. I just want to hear the back. Aye! All right, now the front. Aye! I'm going to give you one more chance in the back there, and then you go out and everybody else comes in. One more chance in the back. Aye! All right. Okay, front! That's good. See, he caught you off guard with the timing. Anyhow, back to what I had a point here. I was getting to it. There was a shark, and it was eating your crew when you weren't paying attention. This is a really important metaphor. I'll come back to it in a minute. But the truth is that captains and users and those that be paying you and your pirates to go about your day plundering and pillaging and bringing back the spoils of your activities to them, be understanding that captains who don't manage their crew-slaying battery habits are not good stewards to be part of their fleet. And they be using applications like Carrot to identify bad applications that be slaying crew and using their battery unjustly so that you can uninstall it during the day and get rid of it from killing more of your crew, like the shark. See, it was an important point, and I came back to it. That's called going back to a point. I took a pirate speaking course. It helped me, I think, clarify my message since last year. Got a lot of confused emails from people about what the Kraken was and why I went into such graphic detail about how the pirates were slain. Also, some groups that were on behalf of, pirates, let me, anyhow. Hashtag Perf like a pirate. So the question be, how long can you be at sea plundering before all your crew be dead? Let's look at a fully stocked Nexus 5 vessel from the Queen's fleet. Aye, she be a pretty lass, although covered with barnacles. The Queen, I mean, not the boat. Aye. Out of that planks with you. A fully stocked Nexus 5 vessel can remain out at sea for 1 month at a time before your crew get bored and start eating each other for fun. We've all been there. But as you go through your day, the more active things ye be doing when you're not in standby mode, plundering along the shoreline of cellular and Wi-Fi and wake lock and screen, can leave you stranded in the middle of the ocean without any crew and just birds to pick at your skull. Not a good place to be. Sometimes you see these ads online for like free skull pecking by a bird. Don't click on them. They're just money traps. Because you're like, you talk to the missus and you're like, of course we should go out. This would be a great time. We can take the kids with us. But then you never use it. No. Apparently that one was a little too far. So every pirate captain know the golden rule, and that be that 1 second of active pirating and plundering be worth 2 minutes of standby time out in the ocean. This is a very important metric for you captains. This way, you can line up the crew members you like least and have them killed first. Arr! Arr! I found someone asleep. And so then the question we have, if we're doing 50 acts of piracy for 1 second each in a single hour, that's equal to 100 minutes of standby time. Now with these numbers, it's pretty easy to see how fast your crew can be slain, leaving you adrift in the wide open sea. It's math. We be pirates, I understand, but we should still be able to do this. And if I can't do that math, then what's going to happen is the users and the people financing your voyages are soon going to realize that you may not be a good steward of your ship, and they'll stop financing and giving you... I'm trying to figure out if that's coming from up here. No. It's the shark, yar. This is what we call live internet. Someone's probably calling me from the internet right now, like, he's on TV. Anyhow, the point be that unless you be getting your battery handling under control, you're going to end up with a ghost ship out in the sea, with no one to finance your plundering and your pirating. They won't be giving you any gold, any booty, or any rum, which, as we all know, is not why we're in this business. So Captain Mainroach here be with 3 tales of pirate woe. Any man who does not listen to these 3 tales is set adrift on his own course, and I take no recourse for his action. If you not be listening to what I be saying today, woe be you in Davy Jones' locker.
First, we be talking about the ship, the SS Wakelock. Yar, it be a good vessel, but had a naive captain running it. Very insecure he was about his pirating deeds, and he would wake up the crew at very inopportune times during the day and night to do trivial things like count the number of cannonballs or swab the deck or just look at the sky and admire it together. We're pirates, we still have hearts. The sunset is good. But the naive captain had one flaw. He woke up one day in a mad frenzy and couldn't control himself and kept the pirate crew awake for so long that they started dropping over dead. They just fell and fell and fell from exhaustion. He had depleted all of his resources simply because he couldn't contain himself and didn't let them go back to sleep. And what happened was the ship was sunk and eaten by a giant sea turtle. So are we all clear on the metaphor here? Okay, so really quick. So what this is I'm talking about no. Once you say sea turtle, you can't go back. So let us be learning from the ship of the SS Wakelock. First off, there be tasks that ye need to be doing in the middle of sea. But there are other tasks which you can wait till you're plugged in back to port to be doing. For example, downloading updates to your applications, or maybe doing some high compute intensive task of moving cannonballs from one side of your ship to the other. You don't need to be doing these out at sea while your users are trying to figure out if you're a worthwhile investment for their careers. Arr! Arr! I'm the captain, I can say that. Also, you need to make sure that you don't be waking your crew up using a wakelock methodology. You want to be moving to something like a hierarchical system of using an alarm manager to handle it. Does everyone get it here? It's a lock making wake. It's a nautical pun. See, it's a lock and it's a wake lock. Wake. Laugh harder. Arr! I didn't write. I'm sorry, this is my favorite part of the whole. It's a lock making wake. I don't think you understand how hard I worked on that. That was like a whole day. I just chuckled to myself. Like, no, it's a lock, because they sink normally, and it's making wake. This man, someone get him a t-shirt and more rum. Yar! Now let us talk about the SSHTTPS. Apparently we know about this ship. It was run by a vile captain, the Duke of HTTPS, who had a love on the mainland named Servlet. And he loved to spend all of his time communicating with the fair lass that he wanted to wed. But when he was out at sea, he couldn't do that easily. So he had to find a way to transfer his message packets back to her in an efficient manner. But the only thing he could come up with were vile demon birds that used the blood of his crew to initiate their transfer protocol. What is that noise? I'm going to ignore it and keep going. This is an important point. I don't want to touch anything. Is someone Instagramming me? I told you to put that away. Anyhow, these birds out here, how they work. I'm describing birds now because of this thing. So the vile birds used one simple methodology to fly around. He would have to slit the throat of one of his crew to wake the bird from its slumber before it could make its mission. And then he would have to keep killing the crew at regular intervals after the bird took flight in case he needed to find his way back with the messages. Everyone get in the minute. We'll talk about that in a minute. So one Christmas morning, the Duke of HTTPS decided to send many messages of love and lust and promises of smooching to his crew. Or not to his crew, to his servant. I guess the bird wouldn't have to actually fly that far. His week, but I mean, so wait, if he were sending those to his crew, why would he be slaughtering them? Once a minute. Okay, all right, let's back it up. He's talking to servlets on the mainland using the birds that eat his crew. We're gonna get this back in line now with the binging and everything else. We can recover from this. Yar! Yar! I pulled something. So these vile birds would then slaughter his crew and return with messages. But on this Christmas day, he spent so many times sending messages to his lovely servlet on the mainland that he ended up slaughtering all of his crew before he realized it. Now those same demon birds run his ship and is captained by the ruthless Captain Featherbeak. I hate this bird. It pecked at me head for like way too long one day. Remember that head-pecking vacation I talked about? This is the guy. Don't click on it. Okay, moving on. So let us learn from the mistakes of Captain Duke of HTTPS. First off, know what kind of bird you be using for what kind of transfer you be using. You don't need to be sending out packets when you only have a 2G bird available. Why? Because a 2G bird requires the death of more crew members to effectively communicate back with the mainland. If you can batch your messages and wait until you may be closer to use a Wi-Fi bird, this is going to slaughter less of your crew. Wi-Fi bird, it's Nocturnalis arapus it's lazy load, yes, that's the name, the scientific Wi-Fi bird name. In addition to that, you shouldn't be doing the rookie mistake of every pirate captain and sending your birds to mainland, waiting to see whether or not they respond to you. No, you should be using the tried and true technique of bartering with the commissioner of that fair town and have them send you data when things have changed. Such a barter is often known as Google Cloud Messaging System. Yes. This way you slaughter less of your crew and they send the birds to you and they slaughter their crew. This is actually a very highly important technique to keeping your crew alive. Hashtag Perf matters, yar. Now, as you're out in the ocean, are we getting all the metaphors at this point? Now, when you're out in the ocean, it's important to know what kind of resolution you be using. And sometimes you be sending the birds up ahead of you to be looking around and charting the area for where you are. Now, it's important to know that the higher you send the bird, the less energy it uses. It's a thermal updraft system. So you need to make sure that you're using the right resolution bird to get your GPS. I worked on this one a little too hard, I think. The main thing is, if you don't need to be using a bird that gives you 1 meter accuracy, you should wait to be using a bird that gives you 2 mile accuracy, or what we call network GPS. Yar. Yar. Familiar with network GPS? Hands up. Triangular. Yar. Also triangles. Familiar with triangles? Hands up. For those of you who didn't raise your hands, let's try that again. We're talking about a triangle. Do you know what a triangle is? Still some hands that are really unsure if they'd like to participate in tonight's activities. Does the fact that everyone's wearing a pirate hat not realize, like, you're in on this? You either raise your hand or I'm going to keep talking. Do you know triangles? Yar! One of them in the back was like he wanted to check first if everyone else was going to admit to having triangles in their repertoire. He's like, oh, yes, and me try. Oh, no, no, I don't know anything about triangles. I'm not that guy. Please don't contact me for job opportunities. Yar, y'all be a strange crew. Also importantly, when you let your crew sleep, make sure you bring your birds back in. Don't keep your GPS awake when your application be sleeping, because otherwise your birds will land, there will be no crew on deck, and they'll just start eating anything and anyone they want while you be sleeping. This is actually a large, large problem with application performance, just eating all of your crew members while you're actually asleep, because they can't defend themselves, right? Because they're asleep. It's a bird, and it's evil, and it teleports, and sometimes it wakes me up in the night just staring at me. But that's usually, you know what? We're not here to talk about my problems anymore. Hashtag Perf like a pirate. Yar! Now, I got one final story for you tonight. It's more of a song, really. Well, not the song. We've already done that. I want to tell you the story of Captain Lubbers. It was very small. You didn't see it. Captain Lubbers was a mad captain. His ship had to be bright. So he set his crew aflame to create the light. But when his crew were through, he lit the ship too. Something light, yes. I'm a pirate, not a poet. Get over it. I was supposed to click while that happened. Let me try that again. So there was a mad captain. He wanted his ship to be bright. He set his crew on fire to create the light, and then it burned down because he really didn't have a fire extinguisher back then. And how did they set fire? Never mind. And the truth be that the brightness of your mobile vessel does have a direct correlation to how many crew be slain. The brighter your vessel, the more skulls packed upon me graph here. Yar? But the problem is, as a captive application developer, you really don't have too much control over the brightness of the OLED ship malfunctioning, right? Although some of the very smart captains out there are realizing that they do have some control, and this is worthwhile to the users of their applications. For example, the thing you need to learn here is if you don't have to burn your crew, don't. Or if you can, only burn the left half of your crew, like my grandma used to do. Bless her zombie bones. There's some applications out there who understand that they can modify the brightness of their pixels on their screen to use less battery life, which is very important for smaller devices which may not have larger crews. This is still a very large problem today with some form factor ships out there.
Once you go black, don't go back.
Moving on. And I want to tell you something about one of our fine pirate captains that'll also be speaking today. It's pirate Ilya Gregoric. Everyone say it. Ilya Gregoric. When he comes up, you have to say it that way. Ilya Gregoric. When it starts to hurt, that's when you know you hit the right number of R's. Captain Ilya has a fantastic saying that we all try to live by here on Perf Like a Pirate Day. And that's, you can optimize what you can measure. And most of the time, when your crew be slaughtering, you need to know what's causing it so you can effectively go in and fix the problem. Now, there's a fantastic plug-in to your ship. Well, specifically from Qualcomm's class vessels into the Eclipse floorboards that allows you to monitor how your crew be getting slain. This is a fine tool called Terrapin, and you can find it at the lower link there. It's really important how these tools work. Effectively, they allow you to see how standard parts of your mobile device be eating up battery so that you can find a correlation about how the networked radio may be on and the vultures may be buzzing and how that may be actually slaying your crew. This will allow you to then pinpoint what parts of your application ship stack you can then go in and find and optimize. We all got that? Fantastic. They're giving me the time. The other one is a fine tool from the new Android tool suite called Battery Historian. It actually gives you a lot more counter power than Terrapin does, and is actually have new counters for the Android L release to give even more information about battery performance on your mobile device. Arr! I had to say that because someone checked his watch. Arr! That be it for me, lads and lasses. Thank you for listening to me. Remember, perf like a pirate. Yar!
Did you just swap out?
I got it.
Great presentation.
I'm not presenting again. I'm just getting my computer.
What type of watch is that?
It's just a Blinky.
What?
Tokyo Flash.
Yep.
Do you have audio on yours?
Nope. Hold on. Not quite. How do we mirror?
Or you want it, the other one does, yeah, you want to go to arrangement. You want to go to, does that work for you? Or do you want to go
Yep.
extended?
No, that's good. I think that. I think we're getting clipped a little bit, but otherwise, I think we're good. Wait. I think we're getting clipped for some reason. To
Go to optimize for, and go to scale.
think we're good. All right. Let's get started. So news from WordPerflandia. So it's going to be a really tough act to follow. Impossible, I think. Only Colt can do what he does. So I'm going to give you some tips for some of the things we've been working on in the W3C WordPerf group and related topics about some of the techniques they can use to optimize your plundering around the web in particular. And there are 4 things that we're going to cover. Some of them are already available today. Some of them are coming. Some of them are actually still in the works. So we're looking for feedback, use cases, and all the rest. And that's where you guys come in. We're going to go in order of kind of these APIs. There's the best one by far is the Bacon API for faster bacon delivery, and you'll see exactly what I mean. There's stuff like getting connection type, such that you can optimize your apps. You can figure out if users are not getting to your site, which is something that you can't actually do today. And then finally, we're going to talk about some of the work that I've been doing recently with resource hints. So let's start with the best one, blocking loot beacons. So a very common pattern on the web today is you want to track what happens when somebody clicks or when somebody performs an action. And in particular, that's important for things like, let's say somebody's clicking away from your site, or you're trying to just log some activity. So a user clicks on an activity, and you want to record the fact that they're going to a checkout, or they want to buy something. The common way you do that today is, of course, because you're navigating away from the page is getting unloaded, you need to stop the page from unloading. You need to send a request to your analytics server, you need to wait for that to finish. If you're doing it right, and I hope at least you're setting a timeout, you're saying, well, I'll wait for 200 milliseconds or something like that, and then I will resume and actually let the navigation continue. And of course, that is a terrible performance pattern. It's an anti-pattern, in fact, because we're blocking the actual navigation from proceeding because we need to log the actual analytics. So that is why we have Beacon now. So this is a new thing that is now available in Firefox and Chrome. And using this API, you can actually post data to a URL asynchronously. So what this means is that you no longer have to wait, and you can get on navigating to the new page, and the browser will take care of actually delivering the payload that you give it. And it's actually really nice because it's much more flexible than what you could do before, and it actually allows the browser to do better delivery. So we can do things like retries and other things on your behalf. So all of this is already handled. This is actually very similar if you've seen a ping. So this is an attribute that you can actually put on a link that says, for example, please navigate to the site. But when the user clicks on this thing, please also send a ping registering the fact that somebody has clicked on this. This is not supported across all browsers, but Chrome supports it, Safari supports it, and it actually is fairly well established on mobile. So for example, Google Search last year deployed this on all mobile search results, where before you were actually getting redirected to a redirect service, which would then send a 301. So that's an unnecessary redirect, and they needed that because they needed to register the fact that you've clicked on the link. This helped us improve search quality and all the rest. So nowadays, they don't do that. So instead, they use the ping attribute, which allows them to basically send 2 requests at once. One navigates to the actual destination, one logs the fact that a click has happened. So this helps you optimize performance. This works today. This is great, but it's limited in the sense that you can't actually post arbitrary data, right? You can encode some data in the URI itself, but that's fairly limited in terms of the amount of data you can push and what kind of data you can push in there. So in effect, Beacon is an improved version of a-ping. It's supported on both Firefox and Chrome today. And one nice thing is that it actually allows you to send up to 64 kilobytes of data. And this is arbitrary data. You can stuff a JSON payload or whatever other data type you want, and we will take care of just posting that data to the server. So that's available today, and you can use it. And best part, Google Analytics has actually just recently rolled out support. And you can actually enable this on Google Analytics. You do need to modify your code a little bit. You need to pass this additional flag that says use beacon true. So because this is still a new API, we have not enabled it by default. I'm hoping that in the future, we'll just make that the default, and you can opt out if you want to. And we'll kind of detect the fact that maybe a particular browser doesn't support it. But this is by far a much better way to deliver beacons. So for example, if you're using Google Analytics and you're using things like click tracking, today they would actually tell you to kind of inject additional JavaScript code and all the rest and pause your navigations to log to analytics and all the rest. You can avoid all of that and get your bacon faster. So, and this is very important because this is how all of the like ads monetization and everything else works, right? Clicks matter. So one of the goals here was to make it simple, make it fast, and also improve the reliability of delivery of these beacons. So A-Ping has actually had some bad rap in the past on the browsers that support it in terms of the actual delivery rate. It just hasn't been that reliable. With Beacon, we're actually taking kind of a clean slate approach and making sure that that is very well handled, and we're seeing very good results there. So definitely something that you want to check out. Use it today, available today, awesome. Next, we have forecasting network weather. So sometimes it's actually very useful to know what type of connection is a user currently on. For example, are they on a cellular connection or are they on Wi-Fi? Or, God forbid, maybe they're using Bluetooth tethering or Bluetooth to access the internet. And also, it's also useful to know more detailed data for things like, well, how fast is the link that they're on? So the fact that I told you that the users on cellular is not very useful by itself because there's a lot of variety there, right? There's 2G, there's 3G, there's LTE and LTE Advanced and all these kinds of things. So we're now exposing two attributes, and downlink max is actually really, really fresh. This is something that we just recently added to the spec. So let's look at the actual logic here. So first of all, I guess let's talk about the use case. So this is a recent headline where Facebook is actually using bandwidth targeting to deliver a different experience. So in this particular case, this is for advertising. So they detect you happen to be in a slower connection. So it doesn't make sense for me to try and jam a video ad into this pipe because you're not going to even see it. Frankly, it's going to take you like 10 seconds to download it, right? So that's bad experience. So that's one use case of how you could use this sort of information. And note that we're not saying here that this is the actual download speed of the client. We're just saying this is the maximum potential speed that you could get, right? All we know is the last hop. Similarly, you can actually use a lot of this data to do analytics. So I've actually talked to a number of companies that are currently segmenting this data based on segmenting their conversion data on connection type, and they're finding different performance for things like, hey, we're getting a lot more conversions on 4G versus 3G and all the rest. And that is actually a good signal to tell you that, hey, there's maybe performance problems on 3G that we need to optimize to up the conversion rates and all the rest. So analytics, customizing what you deliver, what types of assets you deliver. Maybe you want to pick a lower res image or skip the video and other things like that. So downlink max is a new attribute that we're adding. And what it reports is the actual megabits per second of the last hop link. And this is very important. So what we're not telling you is like, what is the expected or the current bandwidth of the user? Because frankly, that is a very hard problem. It's a very transient thing, especially on cellular network, where these things kind of go up and down all the time. So instead, we're just saying, look, we know that the user is connected to an LTE network. That's all we know. And on LTE network, the maximum theoretical speed, right, regardless of what carrier you're signed up with, the maximum theoretical speed, like as written in the spec, happens to be 100 megabits per second. So when you query that value and it says 100 megabits per second, that's not to say that, like, great, I'm just gonna like dump the 4K video ad on the user, right? Like that's not what we're saying. We're just saying this is the potential, the maximum. And this, of course, becomes very useful for kind of the lower range of the pipe, where you start looking at 2G connections. Which are still very much prevalent. And believe it or not, you can also, like I'm sure you've all seen it, we get bumped down to 2G even around here every once in a while, right? You go to a big event, you're on 2G. So this is where you can actually use this sort of logic to say, hey, I'm currently on 2G, I'm gonna fetch maybe a different set of assets, or I'm gonna do something else, optimize my experience for the user. Now, there's another important digression here. Carriers have pulled a fast one on us. Well, it's not just carriers, but they still pulled a fast one on us, right? We love to talk about megabits per second. Megabits and megabytes are very different things, right? So, sorry? 8 times different, exactly. So the next time you're hearing like, oh, I did a bandwidth test and my phone is really fast. I'm getting 10 megabits per second, right? Like and I'm downloading a 1 megabyte image. If you actually do the math, right? Let's say you have a 10 megabit per second connection, which is actually really, really good. That's about 1.2 megabytes per second. So if you had a 1 megabyte image, which is actually not crazy with our super awesome double retina, something advanced super screens, that's double retina, exactly. HD, retina HD, right? That's the word. It'll still take a second to download that image, right? And more likely, you're experiencing much, much slower speeds. So you have something like 2 or 3 megabits per second, and it will take 4 seconds, right? So this is an important digression, but I think it's something you need to keep in mind. Megabits and megabytes, don't confuse those things. And the spec actually reports it in megabits because that's how the industry kind of works. All right, so that's NetInfo, and NetInfo is available currently in Chrome and Firefox, and we're currently implementing the max bandwidth stuff. So hopefully in the next stable release, that'll make it there, but today you can already query for type. Next one is what I'm calling sea monster detection. So there's actually a subtle problem that we have today on the web, which is if the user can't even reach your site. So for example, before we can log the fact that somebody has visited your site, right? First, we need to find the IP address, resolve the IP address, take the name and find the IP address of that. Then we need to perform the TCP handshake and all that other stuff, and then we can only send the HTTP request. So there's a bunch of steps in here that are basically invisible to us as web developers. And it's actually not uncommon for users to fail somewhere in there, right? So you send your UDP packet, and it gets lost, and you have no idea because the visitor never made it to your site, right? The DNS timed out, maybe you experienced DNS problems, or your server's overloaded and the visitor can't even reach your site or establish the connection with your HTTP server. Those things are just go unreported unless you actually have some users kind of telling you that through a side channel saying like, hey, I can't resolve your DNS, and this is a problem. So for that, we actually have the navigation error logging API, which is currently in the works. There's no implementation of it yet, but I think we actually finally have the spec nailed down or very close to. So expect this to come soon. So how does this work? One way it could work is when the user comes to your site, you can actually call window.performance get navigation errors and just iterate through past errors. So if the user has had problems accessing your site, this would actually contain a full log of like, hey, I tried to open your site on Friday at 5 p.m. and I experienced a TCP something problem, right? And this is how long it took for this thing to time out. So of course, you can use that information to then log it into your backend and do all of the analytics that you want. But I think we can agree that that's kind of like, that's after the fact, that perhaps not as useful, right? Still nice to have, but not as useful. So what we also support is this method called enable navigation error reporting, which does live reporting. So whenever so first you have to come to the site, obviously at least once, right? Where you would invoke this code and basically says, hey, this site would like to start tracking the error reporting, or we'd like to register for error reporting moving forward. Next time, if the user experiences an issue, we will actually pull out that URL that you told us, and when the timeout happens, or when the connection fails, we will just beacon that information directly to that endpoint. And of course, this is the important part here, you should beacon to somewhere else, right? Because if I can't connect to your awesomething.com and I'm trying to beacon to awesomething.com, that's not gonna work. So you want to have like a third-party service or some other domain that is separate where you would send these reports. And this way you can actually get real-time reporting of like, hey, there's DNS timeouts, or maybe I'm getting blocked somewhere, or TCP connections are failing, and all the rest. So this is very, very cool, because today, in order to get this sort of data, you basically need to control the client and the actual site as well. And only the largest companies can do that today, and it's very hard. So this will be really awesome for just improving reliability. And then finally, we're getting to just faster navigations. So there's a bag of tricks here that we want to talk about. This is some data that I just pulled up from my own browsing session. So I'll show you guys some examples later, but if you go to Chrome histogram, anybody been to Chrome histogram before? Open a new tab and just go to Chrome histogram. It has a very long page of like all the different metrics of everything that happens in your system. And it's just histograms of like everything. Just type in TCP and you'll get like 15 charts. So what I looked up in there is like, what is my median DNS resolution time? What is my median TCP handshake time? What is my median TLS handshake time? And all the rest. And by the way, this is based on like 10,000 samples, and this is based on a last day of me just using my computer on this Wi-Fi, right? So you'd expect this Wi-Fi to be pretty fast. We do a pretty good job of it at Google. But nonetheless, you can see that things like DNS handshakes, TCP handshakes, and all the rest, or DNS lookups rather, take quite a bit of time, 60 milliseconds, 35 milliseconds. If I add all of this up, for a typical page, a median page, it takes about 200 milliseconds for me just to establish, kind of perform all the ceremony before I can actually even send the HTTP request. If you substitute numbers for things like 3G or 4G, this very quickly adds up to 1 second of latency, right? So there's a lot of latency that is just spent on the initial setup and the ceremony. And browsers do a lot of stuff to try and hide this. We have things like, hey, let's try and pre-resolve all the links. So when we open a page and there's a bunch of links, we just like, let's just look up all the DNS names, or at least some of the DNS names, such that when you click on that link, we don't have to wait. Let's pre-connect. So before you even click on a link, or as you start to hover towards the link, we'll just say like, hey, it looks like you're going there. Let's start to pre-connect, right? Because between the time that you actually get to the link and click, that's a couple of 100 milliseconds. And a couple of 100 milliseconds counts, right? Because by that time, we could have established the connection, and we can send HTTP request immediately. So that's pretty sweet. And then there's things like prefetch and pre-render, where we can actually just say, like, look, I think this user is likely heading in that direction or into that page next. So let's prefetch the resource, or let's just pre-render the entire page. We'll just like literally create a hidden tab in your browser. We'll pre-render the page, and when you actually say like, yes, I want to go there, we'll just swap it out. And it loads instantly, but we're just really swapping kind of behind the scenes the actual rendering, the renderer. So these are tricks that are available across most of the browsers today. And in Chrome, you can actually inspect all of this stuff. If you go to something like Chrome DNS, so once again, open a new tab, Chrome predictors, and Chrome histograms. Between these three, you can actually see all of the different things that we're kind of doing under the hood and trying to predict and all the rest. So Chrome actually learns quite a bit about your browsing patterns. So over time, as you use it more and more, we actually observe things like, hey, what are the first 10 tabs that you open in the morning when you open Chrome? We'll remember that, and next time you open it, we'll just pre-connect to all of those sites immediately. So, yes, you're going to check the news, you're going to open Gmail and something else. These small tricks do a lot to improve user experience. And the interesting observation here is that the browser does a pretty good job of this, but site developers, you guys, have a lot of knowledge about your own applications, right? If the user is expanding, let's say we're looking at a sports app, right, or a sports section, and if you know that the user is always navigates to the NBA section and then clicks on whatever team, right? Like that's just what they do each morning. Or whenever a user expands a particular section, then they go to something else, right? You know these things that the browser doesn't. And what we really need to do is provide you the same sort of primitives, access to the same primitives, so you can hint the browser to say like, hey, I think the user's gonna do this next. So start doing your stuff. So that's what these resource hints are, right? We have three: pre-connect, preload, and pre-render. So the quick anatomy of this thing is basically this is a hint. It's a link element where you say, you put a resource name. We'll talk about the rel, which is the pre-connect, preload, or pre-rendered. That's the type of a hint. There is the as, which describes the type of the asset that we're talking about. So this is basically like, I want you to fetch this as if it was a style sheet, or as if it's an image or something else. So this just allows us to prioritize the fetches more better in the browser. Then there's the actual link, and of course, media queries. So you can say, look, this hint is only relevant if I'm on mobile, right? And my screen is thus big, or it's only relevant for high DPI screens and all the rest. So that's as expected. Oh, and probability, so we'll talk about that. So let's look at the simplest one and the first one, pre-connect. It basically just says, look, there's a lot of latency that is spent just doing the DNS, the TCP, and the TLS, are all the things, right? So what we can do here is we can say, look, I think I'm going to be fetching resources from the server. I'm not yet sure what resources exactly I'm going to fetch. So for example, you have some dynamic thing that you need to fetch. Like I know I'm going to have to connect to an ad server and request some ads. I'm just not sure what they are yet. So just start doing that now. And by the time you're done, I'll probably know the actual URL and everything will be much better. But then you can also say, look, sometimes I'm not quite sure. Like I may need to connect to this thing, but maybe not. And that's why we have probability. So probability allows you to express some sort of notion of like, I may or may not need this thing. And you'll see why this becomes more relevant for some of the other hints. But this is one of those things where you can be anticipating user behavior, right? You could say, well, if the user expands the NBA section, I will need to connect to these 5 things to fetch these other images. And I think the probability of the user actually doing that is about 0.75, something like that, right? So if you tell us that the probability is 1, it basically means it's a required hint and the user agent must execute it, whereas everything else is kind of up for grabs, right? The observation here is that these are speculative optimizations that could, in fact, request extra resources which may go unused, right? So if you're really, really aggressive with all of your prefetching and all the rest, you're going to fetch a lot of data that you never use. That's also not good, right? Because you've consumed users' data plan, battery, and all the rest. So as an example, let's take 2 hints, right? We have a pre-connect with 1.0 and pre-connect with 0.4. Depending on how the user agent is currently, or how the device is doing currently, it will say, great, look, I've got full battery, I happen to be on Wi-Fi, I got a ton of resources, I'm just gonna follow this whole thing, right? And in fact, for 1.0, that's pretty much guaranteed. But for a low probability hint, something like 0.4, like you may or may not use this, and I happen to be running low on battery, you know, like maybe I'll skip the hint entirely, but for this case, maybe I'll just do the DNS pre-connect, right? Or the pre-resolve, rather. So the user agent reserves the right to kind of shift some of the work and figure out what is the optimal strategy to kind of improve the user experience here. Next, we get to preload. So this is kind of interesting. This is basically a declarative way of saying, I need this resource. So pre-connect was just a way for you to say, I need to connect to that server. And that's important because it just takes a long time. For preload, this is basically like, think of this as XHR, kind of, but in a declarative way. And what you're saying here is, look, I will need this critical CSS file. Please fetch it as if it's a style sheet. I will definitely need it. Only fetch it if the screen matches this media query, or if this media query is matched, rather. But the difference here between fetching this as a regular style sheet is that it's actually not processed. This is just downloading, right? Like, please just download this. Don't parse the CSS. Don't execute it. Don't apply it to the current page. I will tell you later when I want this to be applied. This is really cool because today, whenever you include a link rel style sheet, we actually block rendering on that because that's just how CSS works. So now you can actually decouple these 2 things and say, like, download this now, and later I will inject it into my DOM and all the rest, and you can apply it and do all the other things that you need to do. So this is really, really useful, and it will solve, I think, a lot of problems for us. And then finally, we have pre-render. So preload is something that you would use to fetch resources declaratively for the current page, things like critical assets, additional assets, and all the rest. And pre-render is something that you can use for the next page, where you can say, look, I think the user is heading in that direction next, and on that next page, I will need these CSS files, these images, maybe it's a big product image that you want to prefetch, or pre-render, I guess, and such that it's displayed very, very quickly. And perhaps the biggest difference here is when the user starts navigating towards the new destination, we don't cancel those requests. So today, if you think about it, if you initiate a bunch of XHR requests, and then the user clicks away, we will actually cancel all of those, right? That's just how the process works, because we don't want to persist those requests because, well, you're navigating away from the page. So why would we cancel all the things and let's move on to the next page? So pre-render actually allows us to, this is a hint to say, like, I think I will need this on the next rendered page, so please don't cancel these things and let them continue. And then the next page can make use of them. So this way you can actually use a similar strategy as I described before. As the user's heading towards that link, you could say, like, I know what they're heading. I know where they're heading. I will need these 5 resources. So start fetching those now. And then the next page can be rendered much faster. So here's kind of a quick overview of how this actually works and where you would use it, right? We have fetch start here at the top. This is where we just start fetching the page. And you can inject a bunch of hints right at the beginning of the page to say, look, I will need to pre-connect to these servers. I will need to pre-fetch these resources, do all that for me. So this is a way for you to help optimize the initial render. Once the page is rendered, you have all of your regular tools. You have the XHR, the images, the scripts, and all the rest. None of that has changed. Everything's the same. Then finally, there's another transition here, which is the user is navigating away or towards a new destination, and you can say, look, this is great. This is where you use pre-render, because you inject the pre-render hints on the current page, but they will be used on the next page, right? So it's that's the only distinction, really, the important distinction between preload and pre-render. So this is a working living doc. There's a lot of examples. The spec is something that we've been working on in the WebPerf group for a couple of months now. Please check it out on GitHub. There's a lot of examples in there. I would love to get your feedback in terms of what are the other use cases that perhaps are missing, that we're not covering, and all the rest. So take a read through. I tried to keep put as many examples in there as I could. And this is a quick summary. If you're not familiar with these APIs, just follow these links. I'll share the slides, and you don't need to copy that because you can actually find the slides at Pirate Perf and Perf Matters. All right, thank you. Peter? So I think we have, let's see, where is Peter? So I think we have a break. Is it 20 minutes? 30 minutes. There he is. Hold on.
So let's get back at Let's get back at 8:05. Thank you. There's some more drinks, wine, and everything in the lobby there, and dessert.
Ahoy, me hearties! All hands on deck. Ahoy, me hearties! All hands on deck. Ahoy, me hearties! All hands on deck.
All right, we're gonna get started in 1 minute. Where's the lightning? Lightning dude. All right, 1 minute. So you're on. Seconds. 30 seconds. Thank you. All right. All right. Hey, guys. Welcome back. So we've got a couple of two quick lightning talks. Shreyas and Carlos will be talking to us, and then we'll have the next two talks. Shreyas.
Thank you. Hi, guys. I just wanted to announce that there's another meetup coming up, and I'm speaking on mobile UX, especially how it affects performance, particularly perceived performance, and what in the UX realm you can do in your applications that make it look it's fast. And then we have another speaker, Steve Stouters, who's going to be talking about web view performance. So for all the mobile web developers or hybrid app developers, the talk will cover like how do you shrink the gap between native application and HTML5 application and make them so that the user can tell the difference. So I'll put a link on the meetup comments, so you'll get a notification, and the talk is on September 30th. What's the meetup name? It's called Silicon Valley Mobile Web Developer Group. So Google that, or I'll put a link in the comment section. Thank you.
Hi guys, my name is Carlos. I'm the CEO of Product School, and we teach product management for software engineers. It's a core 6-week program at night in San Francisco, very close to Google. And we are giving away one free scholarship for any of you. So if you just want to learn more about product management, just send me an email to carlos@product-school.com, and we'll be giving away one scholarship is worth $3,000. Thank you very much.
All right, thank you, Carlos. All right, so a couple of quick notes. We've got a couple of great raffle prizes: Chromebooks, PS4, wine, lots of other great stuff. So hang on to your badge, because your badge is actually a raffle ticket tonight. The other thing, hold on. Okay, good. The other thing is, if you could, at the end of the events, I heard a lot of people really like the event, but we really like it if you send us a couple of comments on Meetup. So many people tell us it's great, but then they leave and they don't leave us any comments. So we really appreciate it if you leave some comments on Meetup, give us the rating that you think we deserve. And that really helps us, so great. So without further ado, I want to hand it over to Chet, who's going to be talking about web performance and tools and tips, lots of other stuff. Great, thanks. You've got it.
I guess I have a mic here. Everybody can hear me? Are we good to go? Yep. All right, so a couple of months ago, Colt asked if I would come give a talk tonight. It was much later that I found out that I was supposed to talk like a pirate. On the other hand, it was also later that I found out that I was going to be giving a talk at an HTML and web conference. And I'll just say, screw it, because tonight I'm going to talk about Android, and I'm not going to talk like a pirate. So, on with the show. So I want to talk about tools of the trade in Android performance and pirate craft, and also some tips and tricks. If we have time, I have some demos, a little bit of case studies we can run through. I'm going to have to talk pretty damn fast to get there, so we'll see how far we get. If you are a pirate, obviously you need some tools to accomplish your job. You probably have a ship. You certainly need a chest for all that booty you're going to pick up along the way. Everybody needs a parrot. And then you probably have some enemies that you want to slaughter along the way in various ways. You probably also, I mean, it's a wooden ship. Maybe a screwdriver comes in handy and a hammer, and of course a chainsaw. On the Android side, we have some useful tools as well. First of all, we should find out how many Android developers are here. Android developers, go. Okay, not as many as I hoped, but more than I feared. So, we'll talk about some tools that maybe the rest of you haven't heard of before, but when you get to Android development, and I will say when and not if, then maybe you should be tuned into what these tools are. First of all, we have TraceView. This is your basic profiler. It tells you where you're spending time in your application, and it tells you the call stack of how you got there. It's a really good way of understanding the call flow and the expensive routines, the bottlenecks in your code. One thing to be aware of with TraceView is the exercise of instrumenting your code on the fly means that method invocation is more expensive than it would be otherwise. So it will give you a really good idea of how much time you're spending relatively in your code, but not absolutely in your code. So don't take the times for granted, but instead just sort of understand where the bottlenecks are relative to other things going on in your application. Next tool, Hierarchy Viewer. This is an awesome tool that we use a lot on the Android team to understand what hierarchies look like. Most times we use it and pop up an application like, let's say, the Play Store, and we understand how horrifically complicated view hierarchies are. And it gives us a really good idea of what to tell people to do, which is don't use so damn many views. Because the more views you have in your application, the more time we take to actually draw them on the screen. Even if they're hidden off screen somewhere, we still have to run through the hierarchy and process information about them. So this tool will give you a nice visual representation of what's going on with your hierarchy. If it's too small to see over on the right there, you see a really flat hierarchy with tons of stuff spooling out to the sides. That's maybe an indication that you could go a little bit simpler. It also gives you a good idea of what the properties are in the views at runtime, so you can poke into any of those nodes, see what it looks like, and see properties like, is it invisible? What's the alpha value in that thing? What are the layout parameters? It's a good way to debug the runtime situation of your code. Very useful tool. There's some caveats with it. You need a user debug or an eng build to use this thing. Otherwise, you need to use something called View Server. Look for it out there. It's available. It's a little bit of setup in order to use this tool, but very worthwhile. Tracer for OpenGLES. This came online in, I don't know, maybe ICS timeframe. Really good for game developers who use OpenGL. Also good to understand what the graphics commands are that are happening underneath any Android application. It'll basically show you all of the commands that we're spitting out to the GPU, the OpenGL commands, and it'll show you what the textures looked like at that time, what the programs, shaders, the state of basically everything going on in the GPU at runtime for every single frame. Very useful hardcore debugging tool, performance optimization tool. Another one that came online in, I don't know, maybe Jelly Bean, Systrace. This is awesome. I'm going to show a little bit of output from this later as well. This is a really complicated tool to understand, but it's worth your understanding it. When we worked on Honeycomb, the 3.0 release, we kept banging our heads against our desk because we would be running an application and it would stutter, and we would trace through the application, try to figure out where the time was going, and it was clear that the time wasn't going to that application, it was going on to something else going on in the system. And we always wondered, well, how can we find out what else is going on in the system to cause this hiccup in the application that I'm trying to tune right now? And this is that tool. You all kinds of different output. You have options. I want to see the view hierarchy. I want to see input. I want to see vsync. I want to see CPU information. All this information about what's going on system-wide so you can see how your application and how your animations and frame rate is fitting into the rest of what's going on in the system. So a very high-level tool. It's not showing you the entire call stack, but it shows you some really interesting elements of how you got into that particular bottleneck in your code. For example, if you're running layout during an animation, you're going to see it called out in really long draw calls on every frame and layout information on every frame. It's a good performance analysis tool for all kinds of situations. You can also use some tools that are built right into the device. You don't even need an IDE for this stuff. Or the monitor tool. Instead, you just enable these things on your phone. So we have profile GPU rendering. This one's available from developer options. And everyone knows how to get developer options, right? Tap 7 times on the build. It's awesome. It's the best Easter egg ever. So then you enable developer options, and it gives you a little toast saying, congratulations, you're a developer, and that's how you know you are awesome. So profile GPU rendering is one of the many developer options you can enable, and this will show you in real time the graph of frame rate. So it'll show you this little green bar at the top, which represents 60 frames a second, and then the histogram at the bottom shows how close to that bar you got. And smaller is better, right? We want to spend less time every frame because once you pop over that green bar, that means you caused a frame of jank. You hiccup for a frame, the user probably noticed it and had a bad time. So another tool that's enabled on the device is Overdraw. This came online probably in Jelly Bean. It will show you with color depiction, a couple other options. If we have time at the end, I'll show a demo of this. You can see how many times you're drawing each pixel. This is really important because it takes time for the GPU, for the entire system, to draw each pixel on the screen. Obviously, it's doing some work, right? That means every time you redraw that pixel, it takes a little bit more time. So if you have a situation where, let's say, there's a background on your window, and then there's a background on your layout, and then there's another layout on top of that that has an opaque background, and then there's a button sitting on top of that that's opaque. The pixels that represent that button were drawn 4 times. If all you're seeing is the background of the button, why did you draw the rest of those things? Right? So there are ways to optimize that. I'll get into that a little bit later. Overdraw is a really good thing to watch for in your application. If you notice that you're not getting the performance you think you should, if you're using the previous tool to see what GPU performance and frame rate is like, and it's not as high as you think it should be, check your overdraw. This is a really big time sink for a lot of applications. So let's go through some tips and tricks. So we have tips and tricks for pirates, obviously, and we also have tips and tricks for Android programming. So don't wear your pirate in a sword fight, or you'll have a bad time. On the Android side, let's avoid overdraw. We talked about this already. GPUs are terribly fill rate limited, and this depends on the device. Some devices are better than others at handling fill rate, but in general, you want to overdraw as little as possible. So we'll get into a demo. I think we'll have time at the end to see a little bit of that, and you can see what I'm talking about. Don't bring a cutlass to a musket fight, or you'll have a bad time. On the Android side, use hardware layers. So every time we draw a complicated view hierarchy, we're going to issue commands to the GPU that represent every little piece of that. We're going to draw an opaque background. We're going to draw a shadow. We're going to draw some lines. We're going to draw some text, some bitmaps, some 9-patch, all this stuff that has to render for a complicated view hierarchy. That's all great if you have to draw it. But let's say you have that complicated view hierarchy and you want to fade it out, right? You're doing a transition to a new screen and you want to nicely fade that thing out. We're going to issue every one of those tiny little commands on every frame. Wouldn't it be nice if you could just do all that complicated rendering once and then a simpler operation every time we fade it to a transparent representation? Well, you can do that with hardware layers. You can say, I want this thing to sit in a layer, and then what we're going to do is we're going to draw everything once into that layer, and then every time we go to fade it out on every single frame, all we have to do in the GPU is copy a texture with a little bit of alpha information to draw at the correct translucency. Way cheaper. So enable layers. Very importantly, there's a demo at the end. I don't know if we'll get to. Very importantly, don't enable them full time. Don't just set layers on your views because Chet told you that's a good idea, because he didn't. That's not what he said. Go back and watch the talk again. Layers are really good for animations. They're very good on a temporary basis. But two things about them that are bad to keep around permanently. One is that they take up as much memory as they are large. That's not grammatical at all. However big the layer is, that's how much memory you're taking up. So if you have a view that's the size of the screen and you're going to make it a layer, that's fine on a temporary basis, but you don't want a screen-sized buffer sitting around in texture memory full-time taking up all that memory, because that's memory that the rest of your application, the rest of the system cannot have as long as that layer is sitting around. So don't take up the memory full-time, and also don't make us recreate the layer. If you create a layer on an object and then you cause drawing operations that make us recreate the layer, bad thing. Not only are we recreating the layer, which is really expensive, but we're also drawing to a layer and then copying to the screen. So we're actually doing more work every time we recreate the layer on every frame. So do it only for situations where you're not recreating it, and do it temporarily, like during an animation. And we'll see a little bit of code later for how you can do that. We'll see a little bit of code later for how you can do that. See the previous sentence? Okay. Charge your GPS before you leave the harbor, or else you'll, I don't know, get lost, I guess. Don't use too many views on the Android side. Basically, make sure your hierarchy is only as complicated as you need to. There's so many applications that I see in hierarchy viewer where they will have a string of layouts, one after another. They got a frame layout here, and that's a parent of a single child that's a linear layout, which is parent of another linear layout, that's a parent of a custom layout, that's a parent of a... Why? You could have put that all in one view. More than that, you can actually collapse entire view hierarchies into custom views when it makes sense. Calendar is a really good example of that. They had this really complicated view situation, this hierarchy to handle this situation where they needed text up here and they needed a custom color down here, and then they had this little button thing done, and there was lines, and it was just this explosion of views. And what they did was rewrote it as one single custom view. And then the drawing code in OnDraw can take care of how to actually render that thing. And you can process your touch input however you want, right? So there's a little bit of custom code to make this work, but in some cases, that's the right choice because it can simplify a really complex view hierarchy for you. On the pirate side, remember where you buried your treasure, or else, obviously. On the Android side, be careful with alpha. So this relates to the overdraw thing I talked about before. Every time you draw a pixel, it costs you. That means that if you're drawing an opaque background and then you're drawing a transparent object in front of it, you're going to draw opaque first, then you're going to draw transparent on top of it. And sometimes that transparent pixel costs a little bit more because it needs to read the color behind it, process it, blend with it. Not only that, but sometimes the alpha operations cause us to go create an external bitmap or an external buffer, draw into that buffer, and then copy it over. So alpha tends to be expensive. That doesn't mean don't use it. That's not what I said. It's a fantastic effect to use, usually on a temporary basis, fading things in and out. One of my favorite performance situations was in, let's call it Jelly Bean, where the notification panel that you would pull down from the top was taking way too long to draw. We were missing the 60 frames a second. We were hitting like 30 on a good day. And it turned out that someone really wanted gray text in the notification items. So they created a black text color, and then they made that text view translucent. They said, oh, and assign it an alpha value of 70%, which meant that every time we drew the text, we would create a buffer, we would draw it out to the buffer, and then we would copy it back translucently. Cost a lot of time and effort to get what they could have gotten if they just said, oh, by the way, give me gray text, which was the right approach. So be aware of alpha. I didn't say don't use it, but be aware that it does cost. Don't tell the others where your treasure is buried, or you'll have a bad time. On the Android side, reuse your rendering objects. This is kind of a tip about GC in general. If you're in your onDraw command and every time you hit it, you do a, hey, give me a new paint object. By the way, create me a bitmap. Do the following thing. You will stack up temporary objects that need to be GC'd eventually, and that does cost time. It doesn't cost a lot of time, but it will cost enough to cause a hiccup eventually, which means you could be in the middle of the animation when all of a sudden the garbage collector says, hey, I need some more space, stops the world, collects the space, and then you go on. And in the meantime, the user saw a hiccup for a frame. So what was a really nice swooshy animation across the screen in the middle because they were collected, the garbage collector was taking care of all the temporary paint objects that you allocated. Instead, hey, why not keep a temporary one around? You create it once, you reuse it in your draw method. We didn't need to create a new object along the fly. Always wear your sunscreen, or you'll have a bad day. Don't modify your bitmaps often. So whenever you use the Canvas APIs in Android, that turns into GPU commands and parameters and operations. And in the case of bitmaps, it turns into a texture map, right? So you have an image, you're going to create the bitmap, you're going to draw into it, you're going to, whatever, copy your resource into it, and then we're going to upload a texture so that we can then copy that texture around in GPU memory. All of that part's good. But then if on every frame you say, oh, and by the way, I want to draw into my bitmap again, then we say, okay, we can do that for you. So we're going to draw into the bitmap, we're going to upload the texture. Next frame, we're going to draw into the bitmap, we're going to upload the texture. That costs a lot of performance and effort. Sometimes it's necessary, but you need to be aware of it. Just like all these tips, it doesn't mean don't do it, but be aware of it and be doing it for the right reason. Because you don't want us to go to effort on your behalf if we didn't really need to. For the pirates, only attack the ships with treasure, or you'll be a poor pirate. For the Android developers, don't modify your paths often. So this relates to the bitmap point on the previous set of slides. To draw paths on the Android platform, we use software rasterization. We create a bitmap, we draw a path into it, and then, just like I was talking about before, we upload that bitmap into texture memory, right? So let's say you're animating a path. Great, looks great on the screen. That means that on every single frame, we go to the software rasterizer, we have it draw into a bitmap, we upload the texture. We draw into the bitmap, we upload the texture. Draw into the bitmap, upload the texture. Slow, right? It's possible, and if it's the right thing to do for your application, that's fine, but be aware of it. If you don't need to modify the path, if there's another way to achieve your objective, that's probably the right approach. Don't wear your patches on both eyes, or you'll have a bad day. Profile your application, and then when you're done, profile it again. And you might want to do it another time as well. Use the tools that I talked about today, and use any other tools that you want. My personal favorite tool is system.out.println. It works. Unfortunately, a lot of the coding that I do is in animations, and it's kind of hard to do a step debugger to figure out what's going on with the timing of that animation. So I end up issuing a lot of print lines into the log, and then taking a look at the log, and take a look at the time that this thing happened. That works as well. Do whatever you need to see where the bottlenecks in your application. Don't just say, gee, that looks really bad. Figure out why it looks bad and see what you can do about it. See if you're actually running layout during every animation frame. If you are, do whatever you have to get it out of there, because that is going to cause problems forever, right? Do whatever you can to trim down the amount of time that you're spending on every animation frame to make sure that you can always hit under 16 milliseconds per frame or 60 frames per second. If you're a pirate, don't attack the entire fleet, or you'll all have a bad time. If you're an Android developer, do less stuff. We optimize all the time. It's one of the main things that we do in my group, the UI Toolkit group. We spend a lot of time figuring out how to make things go faster, how to cut out the time from all these operations, how to optimize the hardware rendering, the hardware accelerated path. We're doing stuff all the time to make applications faster, but we can only do it on a very generic level. We can do it framework-wide and make decisions about things that applications in general are doing, but we don't know your application as well as you do. Turns out that you know that better than we do. So do whatever you can do in your application. We can't cut out that layout for you. If you tell us to run layout, we're going to run layout, right? But you know when you actually need to run layout and when you could actually set that aside and run it later to make sure that it doesn't happen in an animation. So I'm going to do a time check. Do we have any idea how much time I have? I have 7 minutes. I have time for a demo. Yay. All right. So we're going to talk about overdraw. I'm going to see if I can get the Wolf Vision to work. Let's see. Everybody see that? Squint. Squint a lot. What am I supposed to do here for the Wolf Vision? I did. Anybody in the back of the room? Hi. Anybody in the back of the room that knows what's going on here? I'll just hold it up really high. Okay. All right. The experts are on their way. Okay, so let's assume that we've run this demo. It's really awesome. It's a pretty basic application. Oh, come on. Well, okay. You know what? There we go. Expert, yay! What am I missing here? Yep, 3. Oh, turns out the wire had to be plugged in. You're right, it was a wireless problem. Yeah, could everybody turn off their wireless, please? This demo is not up to this level of preparation here. All right, so while we're working on that, I think I'll talk about the code. So the situation is I have a very simple application. It has a background, it has a couple of buttons. Turns out the window has a background because the window always has a background in the default theme. Hey, there we are. Oh no, now you're gonna see my password. All right. All right, there it is. So we have a window, we have a couple of buttons. And then I'm going to show you how to see some overdraw stuff. Let's debug GPU overdraw. We'll show the areas. So you see some colors-ish on the screen. You can sort of see a blue tint here. There's a green tint down there. If we go back to the application that's white, it's going to be a little bit easier to see this. So you can see this used to be kind of a really light or white, it's blue, and those are green, and the text is actually red, which you can't see very well on the screen. And what's going on is we're drawing a window background, and then we have an opaque layout sitting right on top of it. So the main layout in my application has a background color, which is pretty typical, right? So I had this light gray background color there. So we're drawing the window background, and then 2x overdraw. We're drawing an opaque background right on top of it. So there we go. Ooh, look at that highlight. Isn't that beautiful? So there's an easy fix to this situation that's typically recommended, which is go ahead and remove the window background. If you're just going to draw an opaque color directly on top of the window background, why do you even have a window background? So this is an approach that I've seen a lot of people use on the web. If you go to Stack Overflow, this is common. And they say, well, just set it to null in your theme, and then go ahead and use that theme, right? So we'll use that background theme, and we'll have a null window, and that's, you know, it's going to work really well. So if we go back here, let's see how well it works. So let me disable GPU overdraw. And go back here, we'll swipe that out of the way, and we'll say, okay, now look really closely. Ready? Did you see the black window? Let me do that again. It's really cool. Okay, as the window came up, it was completely black. Probably not what you wanted, right? But the trick is that the window manager wants to animate your window in. You launch an activity, it's going to animate that activity in. But it wants to do that before it calls layout for the first time. It doesn't want you to go through your creation code, spend a lot of time going out and querying the web and doing whatever silly things you want to do during creation, because then it's just going to be frozen waiting for your application to come back. So instead, it's going to make some very quick decisions about what to do and say, well, what color is your theme? I'm just going to draw that, and we're going to animate the window in, and then we'll call your creation code and get on with real life. And in the meantime, you said, oh, by the way, I don't have a background, and the window manager just threw up its hands and drew whatever it could. And on most devices, that ends up being black. In some situations, I've seen it be garbage because it really doesn't know what to draw, right? So what you want to do instead is have something like this. So we'll draw the other version of the application. I call this one empty background instead of null background. And you can see as it animates in, it's actually got a decent background. So if we go back to the slides, we can see the code that you shouldn't use and the code that you should use instead, which is go ahead and keep your opaque background on your window. And then in your creation code, if you're in this situation, you want to get rid of the window background, go ahead and do it dynamically by setting the background drawable to null during your onCreate call. So window manager has finished the window transition. Now you're in onCreate. Go ahead and get rid of it if you want, if that's the right thing to do. We have 2 minutes. Really quick one about hardware layers. So we talked about using hardware layers. I could show you the overdraw in that demo, but let's not. So we have a situation in this other really simple app I wrote where we have a scroll view. It's got this container in it, and then it has another container with rows, and you got buttons in there. And every time I click a button, we're going to fade in and out the scroll view, right? So this is a really complex hierarchy potentially, so why don't we go ahead and set a layer on the scroll view, and we'll get better performance for it. And we can do that Okay, here's the fading code. We're using view property animator. We're saying fade it out. When it's done, fade it back in. And turns out performance is not great because it's really complex hierarchy. So somebody told me I should use a hardware layer. So I'm going to do that. I'm going to set a hardware layer on the scroll view, and then performance is going to rock. And it turns out that it does for this particular situation. So if we take a look at systrace output, this is one of the performance tools I talked about. You can see in this situation, before the layer, we were taking about 7.5 milliseconds per frame to draw that hierarchy during the animation that was fading it out and then back in. And then we turned on a layer in the scroll view, and life was magical, right? All of a sudden, we've got 3.5 milliseconds, like less than half the time, because it's really fast for us to simply copy textures around. That's great, until you go to scroll the view. And then something else comes up. You're like, well, every time I scroll, it used to take 7.5 milliseconds, and now with a layer, it's more expensive. So what's going on? Two things. One is that you told us to create a layer permanently. Bad thing, right? Because now we're taking up all this memory, just sitting there all the time for this one scroll view. Not only that, but every time we draw it, like every time we do a scroll, we actually have to recreate that layer because something inside of it got invalidated. And that's why it takes more time. And you can see the culprit here is we're actually calling update layer. We're recreating the layer on every single frame. So a better approach, instead of creating the layer on the scroll view, do it instead with view property animator and say, when the animation is started, give me a layer, and that's it. And we take care of it for you. We put a layer on at the beginning, we take the layer off at the end. So use hardware layers, please, but only use them temporarily. And that, me mateys, is the end.
Thank you, Chad. All right. So we've got a Q&A session after the next break. And next up is the service worker is coming. Look busy.
Power.
Power.
The first thing I need.
Thanks, Chad.
Then some video. And then some sound. Where's my sound? Hey, this is going great. Right. Okay. I'm not ready yet, by the way. Ooh, hello. It's good sound. I am nothing without my notes. Hey, here we go. And then my favorite browser, Firefox. I need that over here. Where's my mouse pointer? Right. Where's my Wiimote? No, I had one. No, wait, I had a Wiimote. There it is, here it is. I've got this. Excellent stuff. Number 3 for the screen. Okie dokie, that's great. Hello, everyone. How's it going? Yeah. So, I'm from England, right? As you can probably tell. I'm from a small city called Carlisle in England. And I'm from a small district called Harrowby in Carlisle in England. This is one of the pubs. All right. Yeah. As you can see, they fought long and hard about the name of the pub in Harrowby. The regulars of this pub, they call themselves the Pirates of the Harrowby Inn. And every time, I really like that. For my money, that's the best pirate pun I have ever heard. And whenever I tell people it, they are underwhelmed. But you are all wrong. That is clever and funny. So, we've come a long way, haven't we, since the 90s, 20 years ago. You'll have some friends over, and it's going great. And then maybe 2 of your friends would start having a, oh, we do have sound, excellent. Would start having a disagreement about something meaningless, like the release date of Ghostbusters. But then that argument starts to get heated. You know, neither of them are backing down. But it's okay. You hold aloft the answer. For you are the proud owner of Microsoft Cinemania. Don't know why that disappeared. Let's try that again. Whee! That's probably a good sign that we're going to have massive graphical problems during this presentation. That's excellent. We'll see if that continues. But, you know, it's supposed to give you instant access to the history of cinema, but of course it's not truly instant, is it? Because first you must go to the room with the computer in, and then you turn it on, and clunk, all the fans start whirring, you get the static buzz as the CRT monitor whirs into action. Windows 3.1 slowly boots up. And then eventually you get your desktop. But then it does this. And that really sets your expectations, doesn't it? Because we are in an era where booting up successfully is a fanfare-worthy moment. But by the power of multimedia, you reveal authoritatively that Ghostbusters came out in 1984, and you did that in under 10 minutes. The dinner party is saved. The web really changed everything. With the web, you get the information instantly. No installation is needed. Native apps such as Cinemania and Encarta, they looked out of date really, really quickly. Having a separate app for these things just became weird. The stuff on the internet was better. It was built with this new, interconnected, modern world in mind. The browser runtime started to replace more apps. Email clients, one of the first. But then things like office tooling, video players, code editors even. Native apps became the exception. If you look on the Amazon top selling laptops list, you'll see Chromebooks there. And that's how secondary native apps are. Although that's not true, is it, on mobile? Their native apps rule. And because they build to the strengths of the platform. And a lot of the web predates that. Some of the web is even hostile to mobile. Here's a creative agency that I will not name. But this is what you get when you visit their site on a phone. Choosing your creative agency isn't like buying a pair of shoes. So why don't you make yourself comfy and visit our site on a real screen? But they're right. No, they're right. Choosing a creative agency is not like buying a pair of shoes, because I have never had a shoe tell me to fuck off and come back when I have real feet. If you visit their desktop site, obviously, you get a much better experience. You see the sites they've done. They list the things they're expert in, which, of course, includes responsive sites. This is hostile to the whole mobile platform. The more worrying case is sites that are simply hostile to the mobile web. This is a horrible situation, right? The user has gone to these sites in a browser, potentially following a deep link, and rather than sending them the thing they want, we send them somewhere else, where they can download a thing and install that thing, which they can run, which may contain the thing they originally wanted, somewhere deep within the UI. Every day. Well, no one's saying that's a good experience, right? No one's saying that's good, but it's one that many developers think is worth it to get the users off the web and into a native platform. And why is that? Well, have a think about the native apps that you use day to day. Those are the places that the web has failed. But what caused that failure? What features do those apps have that you use that make them impossible to replicate on the web? For me, it's these apps, really. I use these often, or I rely on them in some way, and they can't be done on the web because of things like a lack of push notifications. This is vital for these apps in yellow. They tell me someone sent me something, even when the app's closed, or something happened. I rarely open TripIt, very rarely, but I forget it's there. But then occasionally it'll send me a message saying, oh, your flight's been delayed, or your flight's been canceled, so it's really, really useful to me. Background sync, of course, the app's in yellow again. They send and receive stuff when the app isn't open, from downloading podcasts to sending that email later when I have a better connection, which takes us to the offline stuff. I depend on this for more apps than I realize, way more. From playing music to checking where my hotel is, to looking up a meeting location. I don't want to depend on connectivity for those things. And of course, we need better performance and better operating system integration, app menu icons, battery stats, payment and account integration. Everything that makes it first class on the platform. The web can't do these things, and that's a bug. But what gives me optimism is it's bugs that we are fixing. We are actively landing code to fix these things. These are the ones I want to talk about today. These require something new. Background sync happens in the background. Push notifications are received and dealt with in the background. Offline isn't in the background, but it requires something to run sooner than the page appears, so it can handle network connections and version control and things. And that thing is the service worker. This is the spec. This moment got a round of applause at Google I/O. Oh, yeah, don't patronize me. Fair enough. I admit I could have dressed this up a little bit. I really like what graphics cards do in this scenario because they're essentially just a circuit board. They don't do anything on their own, but they want to sell themselves to gamers as the thing they absolutely must have. So the boxes they come in are amazing. They're filled with this kind of sub-deviant art, shite artwork. You get the usual terrible sexist stuff that you get with anything to do with games, it seems, at the moment. But also things like the hideous offspring of Yoda and Shrek I found in one box. And, of course, Teenage Mutant Ninja Dog appears on one of them as well. So in that vein, I present to you the Service Worker. That's Mumra the Ever-Living, using his powers of evil to control browser features. What badge? I thought about doing that, but I really couldn't be bothered. I'm sorry. Look, you've got the skull and crossbones on some slides, right? I did that in the airport. I'm so jet-lagged. Okay, yeah, if someone wants to design us a better logo, please do. But this is a feature that's being worked on between Google, Mozilla, Samsung, and other third parties. It's like a shared worker, in that it's shared between many apps, and it has many pages even, and it has no DOM access. Unlike a shared worker, it can exist without any pages. And it's shut down when it isn't in use, keeping the memory footprint small. It gives us this background JavaScript context to do all of this stuff. This is still in development, so if you want to play with Service Worker today, you'll need to use Chrome Canary or Firefox Nightly. And in Chrome, you'll need to go to About Flags and enable experimental web platform features. And once you've done that, you'll need to give the browser a restart. If Chrome isn't your thing, then use Firefox Nightly. Just go to About Config, and you'll need to enable dom.serviceworkers.enabled. Once again, give the browser a restart. I'm going to stick to Canary for the demos because we're here in a Google office, so it would be rude not to, really. But also the debugging tools there are further ahead. Firefox are going to they're going to catch up very, very soon, but not quite at the moment. So if you want to know what's supported and where, this site has the answers. Is Service Worker ready? It'll tell you the status of all of the various sub-features of Service Worker across the browsers. So let's take a look at the offline stuff, because it's the foundation for the other features. Offline suffers from the same misconceptions as progressive enhancement. People say, I don't need my app to work offline because my users have permanent internet connectivity. But it's not just about dealing with zero connectivity. It's about treating the network as an enhancement. It's like, Ilya covered some of this stuff before, but when the user enters a URL or navigates to your site, it creates a new document, but we have to get data for that. So off we go to the network, and this can take a long time, just to get the HTML. And once we've got that, we can't render. We need to send off requests for all of the sub-resources, the CSS, the JavaScript, the images. And as these come back, we can start to render, but not completely, because these start other sub-resources, XHR, fonts, images used by the CSS. And then we can get to a complete render. That can take a really long time. As a practical example, we're going to take this sort of demo app called Train to Frill, a simple responsive site that displays the latest train photos from Flickr. Don't ask me why trains. I was on a train when I started building this, and I had a moment of complete zero inspiration, but it's going to be trains. Let's load it on a phone. Now, we're going to load it with a simulated edge connection, and that's 250 kilobits. So not the best connection in the world, but 15-year-old me would have killed you for that kind of connectivity. It's by no means the worst that you would get on a phone today. So let's load it. 3, 2, 1, go. There we go. We get first render after over a second. That wasn't JavaScript dependent. We get some content after 5 seconds, and then begins the long wait. These images are 200K each. As Ilya was saying, if you're dealing with a device of this density, images are big, and this is what Flickr would give me if I wanted enough pixels to cater for a device like this. Well, we get our first image after over 30 seconds, and eventually, after what seems like an age, we'll get the final image through at the top there, and there it goes. I had to cut that video down. That's not real time. It just takes so long. Those figures are the real figures. Of course, we could probably compress those images a bit better, and we could do something to ensure that the top images load a bit sooner. I just took what Flickr gave me. But we are still winning compared to native at this point, because the equivalent for the native app is the trip to the App Store, the download, the install. It's a slow and comparatively poor user experience. But native kicks our ass on the second visit, because it used that initial download to cache a load of stuff and set a load of things up. We have the browser cache, right? But the whole web is fighting for that cache, and something pointless can override something really useful. And we deploy stuff really regularly. So we make one change to our CSS, and now we have to change the file name of the CSS, so we've invalidated the cache. But this page does something different. It registers for a service worker, allowing it to do something about that second load. This registration happens just with a single line of JavaScript like that, giving it the location for the script. You can also scope it to an area of your origin, which is useful if you have one origin with many apps, such as GitHub Pages. The default is the whole origin, which we'll use here. Registering is an async operation, so it returns a promise. So you get callbacks depending on whether it succeeded or not. You can only register for service workers on pages served securely, HTTPS. Service worker gives you so much control that we cannot afford to let that lie in the hands of a man in the middle. GitHub Pages serve over HTTPS, great place to put demos, and localhost is exempt for development purposes. As for this worker script, we're just going to put in a console log. We're also going to listen for the install event, and that's called when the service worker sees this worker for the first time. So let's see that in action. First, I'm going to go to service worker internals, which is where our debugging stuff is living at the moment. It will move into DevTools, but it's early days. These are all the service workers that the browser is aware of. As you can see, it's aware of none. So let's open the train site, and we'll open DevTools there as well. As you can see down here, we've had a successful, we've got a smiley face, successful service worker registration. If we go to service worker internals now, there it is, and there's our console messages. But even better, we can open an actual DevTools window for that worker. We can run stuff on the console. We can set breakpoints. We can inspect things in detail. If we fast forward time a bit, this worker will terminate. That's not a bug. It closes when it's not being used, and that's just to save memory. And at this point, congratulations. You are now wielding the power of the service worker. But what did it actually get us? Nothing. Nothing at all. But wait. That's actually a good thing. Trust me, it's great that it does nothing. Compare this to app cache. If we give like a page, an HTML page, a manifest, and that manifest contains nothing except the words cache manifest, which is required to make it valid, yeah, sure, I'd expect my page to go from this to this, said no one in the world ever. App cache missed the point of the extensible web completely, almost as much as Disney did with Jake and the Neverland Pirates. A good pirate never takes another person's property. Shit, pirate. Anyway, we didn't want to repeat app cache's mistakes. So service worker doesn't do anything unless you tell it to do something. App cache broke a load of eggs and failed to make an omelet, but it is made of the right ingredients. There's routing, we've got fetching, caching, updating and version control. But in order to get them, you must traverse the piles of implicit behavior, which are, of course, guarded by the army of robot wasps. If you've used app cache before, you'll know exactly what I'm on about. So we got rid of all that. We cleared it away. We separated them out. And we give you the separate parts to use however you want without getting stung. This is the extensible web. Don't let the platform give you a hey, I want the fishing rod, and show me how to use it. But give me the fish as well. This is what we want from the platform. We want high-level and low-level APIs. So first up, routing, putting you in control of requests. The service worker is event-driven. We've already seen install, but there's also fetch. And this is fine for any navigation request to your scope, but also any sub-resource requested by those pages. So in service worker internals, I'm going to start up this service worker and inspect it. And now I'm going to navigate. You can see we've got this fetch event here with the debugger statement. And now I'm going to navigate to the page. As soon as we do that, we hit this debug point for the root page. And if we fast forward a bit, I skip past that, we'll get another request, this time for the CSS. And then we get one for the logo, and then one for the JavaScript. And then we get one for the request to Flickr's API. This is to another origin, but we still get an event for it. And then we'll start getting the request for the images through. And we don't just get the URL either. You can get detailed information about the request, such as the headers, the mode, the referrer, as much as we can safely give you in terms of security. But hey, the cool bit is, it's like other events, such as click, touch start, and key down. You can prevent the default and do something else. You can respond with something else. Responses can be created manually. So there, I'm just creating a new response. Sorry, no trains today. Yeah. Which changes the response from this to this. But the interesting thing there is we delivered that without going to the network at all, making it the first offline demo of the talk, only halfway in. But we can do better than that. When the browser discovers this service worker for the first time, we'll get it to make loads of requests to the network and get loads of responses back. This may be fast, it may be slow. The network is unpredictable. We don't care, because the user already has the page. We're not disrupting them. If all the responses come back successfully, we'll throw them into the cache. This pre-caching pattern is good for stuff that a native equivalent would make part of the initial download, but we get to do it in the background without disrupting the user. For our train site, this is like the root page template, the CSS, the JavaScript, the design images, all the static stuff. And then in future, when we get a request for one of these things, if it's in the cache, we'll just get it from the cache and send it on. The uncertainty of the network is no longer our problem. And this is really simple, thanks to the caching API that comes with Service Worker, giving you full programmatic control over the cache. So in terms of our train site, in the install event that we had before, we're going to call event.waitUntil, and this lets you pass in a promise, allowing you to extend the installation process or indicate its failure. So here we're just going to create a cache, give it a name. That gives us a cache object, and we're going to add a load of stuff to it, all of our static assets. This is an atomic operation. If any of these fail, the whole thing fails. It fails the installation, and this service worker won't control pages. But that means if install succeeds, then we have these files. We can rely on having them as a dependency. Here to tell us a little bit more about Chrome's implementation of the cache API, we're going to go live to Senator Vreenak of the Romulan Empire. Senator, how's it looking?
It's a fake.
Yes, thank you very much, Senator. Tell the kids I said hi. The API that's in Canary at the moment is a complete fake. It doesn't really work at all yet. It's not usable. But thankfully, there is a polyfill backed by IndexedDB. The proper implementation will arrive in a few weeks. But how do we use these cached items? So we can call caches.match as part of a respond call, and we can pass in a request. And that will look in the caches for the response that matches the request. And matching is done very similar to how it works in a normal browser cache, things like method, URL, vary headers. If there's no match, you'll get null back, which is going to start breaking things. But promises let you recover from that. So I can do .then, and if response is falsy, I can do something else. What could we do instead? We could return something else from the cache, like a fallback page. But what if we wanted to try the network? To do this, we need to be able to make a request using JavaScript. So back in the 90s, in 1999 to be exact, Microsoft engineers were working on an exciting new API, but they didn't know what to call it. It contained some initialisms, some acronyms. And they couldn't decide if they should be all caps, like the HTML in inner HTML, or just the first letter, like getElement by ID. So they did both. An XML HTTP request was born. Other than that, the name is perfect. XML, because it only deals with XML, except it doesn't. HTTP, because it's restricted to HTTP, except it isn't. And request, because you get a request object back, except you don't. We've tried to modernize this API a bit so it makes more sense, but it's still pretty bad. Fetching some JSON is still absolutely terrible. We've been patching this API up for 15 years. I do not want to be using this API when it is old enough to drink. Thankfully, the fetch spec by Arno van Kesteren of Mozilla gives us lower-level control over requests and responses. We've already seen some parts of it, the request object, the response object, they're part of this. Lower-level APIs tend to be more complicated and harder to use. But XHR is so bad that is not true here. The equivalent to this in the fetch spec, fetch URL, gives you a promise, parse it in the format you want, gives you a promise, and you're done. This is a forward-thinking API as well, so ES6 arrow functions make it a lot neater. ES7 async functions, you can turn it into a one-liner if you want. It's a bit messy, but it is possible. So to answer the question, how do we send this request to the network? Fetch it. So where does that get us? So in comparison to before, 3, 2, 1, go. We render almost instantly. We get some data in after 2 seconds. That's still coming from the network, but our JavaScript arrived so much quicker that we were able to make the request sooner. Still a sad story with the images, though. But we got to first render really quickly. All of that stuff Ilya was talking about, all of that DNS and network crap, we didn't have to worry about it. We got to first render without all of that. But with these images, let's fix those. When there's a request for a Flickr image, that goes to the service worker, as all requests do. And if we've got it in a cache, we'll just return it. Otherwise, off we go to the network, the long round trip. And once we get a response back, we'll send it to 2 places. we'll send it to the cache and the page at the same time. So next time it's requested, we can get it straight from the cache. We're doing this with Flickr images. It's also good for avatars and things, that kind of pattern. In terms of code, we do this by special casing URLs ending in staticflickr.com, and that's where the Flickr images live. And in that case, we're going to get it from the cache if it's there. Otherwise, we do a fetch, add it to our cache, and send it back to the browser. We need to be careful with this pattern, though, because we're adding to the cache with every request for a Flickr image. So we'll need to garden that cache at some point. We'll pick that up later. But for now, how does that actually improve things? 3, 2, 1, go. Instant render as before. We get content after a couple of seconds. But this time, we've got some images. All of the images we've already seen. Not this top one. We haven't seen that one before. That arrives in about 11 seconds. This is pretty good. But we're still dependent on the network for that call to Flickr, the one that tells us which images to display. Let's fix that. This one's a little bit different. The page makes a fetch request, which goes via the service worker, as all requests do. But at the same time, the page also goes straight to the cache, because pages can access the cache as well. And if it finds a response, it'll take it, it'll render using that result, and that will be all data, and that will trigger the download of all the images, but they're in the cache as well. We'll get to our first view really quickly. Meanwhile, the service worker sends the request to the network, gets it back, and does what we did with the Flickr images. It sends it to the page and the cache at the same time. This is also a good point for us to clean up the image cache. With this pattern, the page makes 2 requests and renders content twice, one from the cache and another from the network. This means we get to render fast of old content, but provide up-to-date content when we get it, if we get it, which we wouldn't if the user's offline. The best native apps do this. Not many, but the best ones do. So here's where we're at. We're special casing static Flickr. We also want to special case api.flickr.com. In that case, we do this. I'm not going to go through it line by line. At the top there, we're fetching and putting in the cache. At the bottom, we're returning to the browser. This gnarly bit in the middle is where I'm going through the caches, finding out which images we don't need anymore by the response we've got from Flickr, and deleting those. Even with promises, this is a bit ugly, but thankfully, ES7 async functions make it really small. And that's the service worker sorted. This pattern requires the page to make 2 requests, though. So over on that side, we make 2 requests, one to the cache and one to the network, and we race them. Because it is possible for the network to beat the cache. We see this a lot on Windows machines with virus scanners installed. Well, probably, you buy a PC these days, it comes with 8 virus scanners installed, and that basically just wrecks disk access times. So the network can be faster a lot of the time. If the cache succeeds and then the network succeeds, we just swap in the data. If the cache succeeds but then the network fails, we silently fail at that point. That's a good offline experience. This is what apps like Twitter do. That's probably too much code to show on slides, I understand that, but my point is we're expressing relatively complex, async, custom behaviors in relatively small amounts of code, even using the low-level primitives. And the effect of that? Well, let's remind ourselves where we started. On the first visit, without a service worker, it took us ages to get to first render and ages to get any content. There it goes. And then the images just took far too long, over a minute for all of them. But with a service worker and the code that I've showed in the slides and the caching, 3, 2, 1, go. And it's an instant render with content. New content comes in a little bit later, and that image will come through in a few seconds. But we've shaved a second off first render. We've shaved over 30 seconds for some images. This is the kind of stuff that Ilya would kill for to be able to do that on the network, right? But we can do it without the network. And you get those kind of response times, whether you're on a fast connection, a slow connection, or no connection. This is what catches us up with native startup performance, and it gives us the foundation for these other things, like push notifications and background sync. These haven't arrived in Canary yet, but they're coming soon. I guess I'm slightly running out of time, but before we look at the code for push, I'm going to try and do a live demo, and we'll see how that works. So, OK, I'm going to do the wolf thing. I'm going to press 3. Yay, that worked first time. Excellent. OK, so what I'm going to show here is a build of Chrome that we have internally. So there we go. This is Chromium. So this is just a simple chat application, and we'll see if this works, see if the demo gods are shining upon me. So I'm going to type in hello, SFHTML5. So see if that arrives on the phone. Come on. Yes, there we go. OK. That's nothing special, right? WebSockets, we've been able to do that for ages. So, but what I'm going to do now is I'm going to close the app. So that's it. There's no apps running at all on this phone. The browser is not running. But I'm going to send another message. And what happens this time is just using open web standards, and there is actually a spec for this, we've received a push notification, a native push notification. And because it's native, it has also appeared on my watch. There it is as well. Just using the open web entirely. As I say, this isn't a custom build at the moment, but we're hoping to ship this stuff in Canary very, very soon. Let's see if we can get back to these slides. So the code for that is pretty simple. So on your page, you register for push. You get some registration details, which will give you the details for GCM, for Chrome, the cloud messaging stuff. Firefox will have their own thing. Apple have their own thing. And then you'll send that up to your server once you've got it. And that gives you the means to send messages to that user later, even if their browser's closed and the site's closed. They will have to grant permission for this. We're not going to give you this for free. They'll get some kind of notification saying, are you happy with the site doing background stuff? But then when the user receives a push message, over in the service worker, you get an event for it. You can look at the data that you get. In our case, we'll update some caches and then show a notification. But you can do what you want. You also get an event when the notification is clicked. Once again, you can do what you want at this point, but it's likely that you're going to open a URL. You can also focus an existing tab as well. I'm running out of time, so I'm going to skip through some of the background sync stuff, but it's very similar to the push messaging stuff. Like if sending an email fails, save that data into a database, register for a background sync saying, hey, sometime in the future, give me a chance to do something else. And in your service worker, you'll get an event, a sync event, look at the ID, and do what you want, which is usually going to be send those emails that failed to send. You can also, this is registering for a single sync event, which is kind of like, I was unable to do some stuff due to connectivity, let me do it later when the user has connectivity. But you can also request an interval sync as well. An interval you specify as a minimum. Syncs will actually happen heuristically depending on how often the user uses the site. And we'll try and coalesce with other events to save battery. With Service Worker, we gain a lot of the features that make native superior, but we retain the bits that make the web superior. Instant on, no install required, open platform. Chrome is going to start shipping this stuff to stable this year, the offline stuff especially, and then next year for some of the push and background sync stuff. Firefox are actively developing it as well. Microsoft are investigating it. We haven't heard anything from Apple, but that's not unusual at this point. Thankfully, it's designed to be used as an enhancement. It won't disrupt the browsers that don't support it. As long as you use basic object detection, as soon as this hits the millions of users that have Chrome, you can start giving them that benefit. Service Worker doesn't make stuff work offline. It doesn't turn push messages into cache updates and notifications. It gives you nothing for free, but it treats you like an adult. It gives you the moving parts and says, do what you want with them. Use it to make things faster, make things work offline. Use it to transcode a video format the browser doesn't support natively. Build a client-side wiki, we've seen that already. Do what you want. Do it in a way that's unique to your app, the way that gives the best user experience. I am heavily biased because I've been involved in the design of this stuff, but I think this changes the scope of what the web is capable of more than any feature since XHR. Let's build some cool stuff with it. Thank you very much.
All right, thank you, Jake. Thank you. So we'll take a quick 15-minute break, and then we'll come back here for Q&A with all of the speakers, plus the great raffle prizes. See you in 15 minutes.
Ahoy, me hearties!
All hands on deck.
right, we're gonna get started with the Q&A. If you have questions, there's an audience mic over there. Just get in there. We got a stranger in our midst.
Yar, matey, what you be doing as a stowaway on my ship? So I have a question about layout performance that I think you'd be answering for me.
The only way I lay is out.
There we go.
Mutiny.
Nice. All right, so don't be shy. Have some questions over there. Otherwise, straight to the raffle. There's got to be some questions. Okay. There's an audience mic over in the middle right here. Right there. Yeah, just go. Yep.
You need to
Walk up to the mic and ask your Android
Thank you.
question.
I have to speak into the mic. Yes. Like a pirate loudly. Okay. Jake. Promises in Service Worker. Why the Promise API in particular?
Well, every API from now on in the DOM is, if it's async success failure, it's promises. That's it. Callbacks are dead for this stuff. Events are only valid if it's an event. You know, if you get multiple of them. So in some ways, things like image load, yeah, that can happen many times on one object.
All right.
Everything is promises now.
Another service worker question. So you said about the traditional web cache that the problem there is that it competes with all the stuff on the web, basically, and that's why it's not effective. But why is that not going to happen to the service worker cache once everybody starts using it?
Yeah, at the moment, stuff in the service worker cache is only gone when you remove it. Like, it's reliable. There might be a permissioning step once you use a certain amount, like over your free quota. But what we want it to be kind of be the user's responsibility, especially if after they've given permission, to remove that stuff. Like, if you go to a website and it stores some stuff in the cache and that makes you run out of space, we don't want it to go and delete Netflix, the Netflix site and all the movies that you've cached for your flight. So it's going to be like the same as native apps. We will promote this stuff in, here's the sites that are using the most disk space, which ones do you want to remove?
Okay. And one more thing, when you, it seems very easy to register to listen to push messages, but how do I actually push a message to your phone?
Yeah, so you'll get an ID and a URL in that object, and that URL will be where you send the messages to as your server, and that communication is going to be standardized as well. So there's going to be even if you get like an Apple one or a Firefox one, the way you send the messages, it will be standardized. You will have to have registered with that service in the same way that you do on Android and things. Thank you. Doesn't work with some pale skin. But yeah, so same message, but different endpoints.
Does anybody else have a question for Jake?
Yeah, actually not to Jake. What's the biggest thing standing in the way for Android performance and browser performance with garbage collection? Which browser?
I heard Android, I heard browser, I heard garbage.
Garbage collection.
Hey, now.
Memory.
I'm just reporting what I heard.
Yeah.
What is the question?
What's the biggest things standing in the way of better performance on Android and also mobile web browser in Android? What are those things? Is it the VM doesn't manage SSD memory fast? Is it garbage collection? Is it caching? What's the biggest things that you can't fix or you're really stymieing?
Nothing's can't, right? It's all just software. So I would say the biggest advance that we've had recently is Art, which is now default. If you take a look at the L preview, Art is not only default, actually, it's the only. So welcome to Art, which improves garbage collection greatly. Actually, we talked about it so much in depth on the Android Developers Backstage podcast that we went on to 2 episodes because we just kept talking and talking. So there's a lot of details about why and how that works and how that improves garbage collection. There were a lot of things about Dalvik that were hampering performance for garbage collection, just how it was written from the beginning that we had a hard time working with. Art allowed us to get beyond those and allows garbage collection to work much better in general. Parallel garbage collection, being able to move very large objects like bitmaps off the regular heap so that everything else that's very small can be collected much more quickly. There's a lot of optimizations that we've been able to make with art, and I think there's a lot more ground to be covered there as well.
Is it optimized for SSDs?
I can answer that question.
I'll look it up. Don't worry about it.
Yeah. Okay.
Cool.
On the mobile web, it's like we're suffering from paint, I'd say, but we're working on that as well.
Cool.
Hi, sorry, I'm showing up a bit late, so I don't know if this question's been asked
Should we go over the presentations again? There were just 4 of us. Okay. It'll take like 2 hours and we'll be done. All right.
As long as there's beer.
Yeah.
Yeah. Sorry, I was wondering, I heard a talk a few days ago about how Instagram, they have part of their app was using WebView, and they switched from WebView back to native.
Yay!
And I was wondering, oh, sorry, maybe I shouldn't ask this, but I was wondering, how can we as developers plan for WebView evolving as well, because we can't always depend on like Chrome features or Firefox.
So we do have Chrome WebView. So that's the answer.
Ah, I see, but then we have to depend on Chrome being installed.
No. So Chrome WebView is a separate thing. It's basically a replacement for the old WebView. And you get all the benefits of Chrome. The platform does, we're working on the self-update story as well. So that's been a big pain point for a lot of people that are using WebView. So you're going to get new features faster. And we're still working out kind of the details of how that upgrade cycle is going to happen. But it's there. You can use it today.
I see. Oh, so it's decoupled from like the OS.
Right.
Oh, sorry. Thanks.
Yep. That was the big change.
Hi, I got a question about service workers. Yes, service workers. Woo! So I was wondering, is there any work being done to create a polyfill for service workers on unsupported browsers, or would that even be possible? Like, would it be possible to build service workers on top of app cache?
Because of the way the ordering of it is that it's more the other way around, that you can build app cache on top of service worker because it's the lower level thing with more freedom. We did actually build a polyfill, but it was a node server that acted as a proxy, and all the service worker stuff ran in the node environment. And that wasn't for, you couldn't use it in production sites. It was just a means for us to test some stuff. Yeah, the polyfills are really going to live in terms of things like the cache API, which are hopefully going to go away soon. It'd be interesting to see if like the Chrome for iOS could patch some of this in with their network stack. That would be exciting, but it's not something we've looked into yet.
Thank you.
Just got a question similar to the somebody else was asking. Just more to encourage discussion amongst you guys and see what you guys our thoughts are on the hybrid or mobile web versus native. And like, if we have all these APIs, HTML5 is opening up all these native functionality, push notification, batteries, so forth. It's bringing closer to the native application development environment. What will the future be? More HTML5 or a mixture? Because like Facebook's apps, I think it's some portions still run on web use, most of it is native. So what is the future looking like?
I lost the thread somewhere about halfway through. Were you looking for like a rumble or like a group hug?
Both.
Okay. So I mean,
Here, I'll do this.
like,
Okay. So the politically correct answer here is that we are in an increasingly device-heavy and mobile world. And as users want to experience your content on these devices, they expect them to have some of the similar capabilities that are presented on the devices themselves. So if you expect that your platform is going to continue to be relevant on these devices, you would expect that more of the device-specific interfaces are going to be exposed over time. This is sort of the conundrum that most of us sit in here as someone kind of trying to bridge both worlds in this kind of argument. As a developer, you have to ask yourself where you're investing your source code, right? Because that's the big thing. Do you write everything in HTML5? Do you write it in Java? Do you write it in C++? Which you should be writing everything in C++ because I expect it.
Only games.
Yes. But the truth is that, in an increasingly mobile world, you should expect that the web should want to adapt to that environment because that's what users are, kind of immersed in right now. And for things to stay relevant and things to move forward, you have to expose APIs in such a way that, users can get attachment to that. That keeps Chet from saying bad things, and I hope that keeps Jake from saying bad things as well.
Let me try some positive things as well. So I think both platforms are advancing on various fronts, right? We're making performance better both on the web and native, and that's good. And if you just take a longer term view, I think there shouldn't be that difference. You should be able to build a really fast and nice and fluid web app and a native app. That shouldn't be the difference. And the users don't care, right, if the experience is good. Then it really becomes a question about what is the thing that I'm trying to deliver? So for example, the web really excels at these like ephemeral experiences where I don't need to commit to installing a thing and like going through a complicated opt-in process and checkboxes. Like I just want to check if the ticket is available for this freaking concert. Right? Like I don't need an app for that. That's a perfect use case for something like the web. Should that feel like an app? Like that shouldn't make a difference, right? So there's like the context is what matters there. And I think we'll find that that's where we're going to be headed increasingly.
Yeah. So I'll just add one final point, which is again, the context matters. It depends on what your application is trying to do. If it's a migration story from the web, that's a great place to start. If it's a really simple application or the UI that you are going for ties in really closely with the way you want to look on the web, that's a great reason too. If it's a really complicated app and you want the greatest performance and you want it to look like the rest of the things on the native device, that's the point at which you start considering native as the real way to go, because these are still constrained devices, right? You have limited battery, you have limited power, you have limited performance, and you need to do the right thing for your application so that it works well for the user in that situation, not so that it works well for the developer that didn't want to spend as much time developing the application that worked well. It worked okay everywhere. So do the thing that works well for the platforms that you're trying to target.
But in terms of developers spending time, right, it's going to take you a lot more time to do an iOS app and an Android app than it's going to do to build one thing on the web. And then you've got desktop
Actually,
as
if
well.
you use C++, you can get it on both platforms.
You can look awful everywhere with C++. I think that's what he was trying to say. No, absolutely. That's exactly the point, is that I think the web as a solution for everywhere is sort of the thing that you would think of first and say, well, if I write it in this, then it's basically the same code everywhere. But is it the right experience everywhere, right? And for some applications, absolutely. For other applications, there's more going on, or there's reasons that you want to target native capabilities or whatever. And then that's the point at which you want to say, well, is that the right solution, or is there a mix of solutions? So we have a Chrome view, and we have some native components, or we have all native components, or all web view, whatever.
Yeah, what the web needs to do is to get to a point where the difference in performance doesn't matter, right? Because this is why we see things like Encarta not happening anymore. We see things like Cinemania not happening anymore, and having a native email client, a lot of people don't anymore, because although native can always beat the web in terms of performance, that performance difference doesn't matter as much. So mobiles, this is why we see, well, like I was saying in my talk, this is why we see much native ruling on mobile, because that difference is too great at the moment. But we're fixing it.
Cool, thanks. Also C++.
All right. Are there any other questions for Jake? Quick.
I have no questions for Jake. I have a question for Ilya, actually 2 questions. From your accent, I detect that you're probably not from around these parts. Where are you from originally? Chico?
That's it. That's what I'm going with.
No, really. Well, I was going to ask you, I think we all anticipated you would speak like a pirate in the argot of your country of origin. Is that possible? Are you from the U.S.?
No. Chico.
You're from Chico, which is not in the U.S.?
No. I think I need a drink now.
I've already had enough drink. It's okay. No pirates?
No pirates.
Come on.
hard C++ question. When Chromium will migrate to C++11?
You mean at the source code level, like Chromium?
Yep.
Does that matter to you? Yeah, is that like a big thing to how you're? So I'm guessing from that question that you're writing some sort of plugins or interfaces or working with Chrome as a fork to roll it out.
Is it a religious thing?
Yeah, I'm trying to figure out. Like if you're writing web apps, you don't care what's running under the hood. If you're writing mobile apps, maybe, but like if you're writing plugins, you should be using Knackle.
It's just a question of a good taste. You know, C++ makes C++11 makes C++ code more, say, readable.
So I'm going to say that a lot of programmers have a lot of opinions.
No, they do not.
And I think if you can look at the crew up here and realize that a lot of opinions are personal, and then a lot of opinions are political, and a lot of opinions are handed down.
Wrong.
Shut up. Stow your noise. And so, like, you know, trying to hypothesize on whether or not a very successful piece of software is to a minor change or even a major change in a language for the sake simply of changing to it is a lot of readability and a lot of rework and a lot of people and a lot of time and a lot of open source systems that have to move around. Is it impossible? No, but there's a lot of decisions and a lot of preferences and a lot of politics and a lot of people between where we are today and where that decision might lie.
So the answer is you don't know.
Yar.
So a good place to ask that same question would be Blink Dev. So if you just go to the group, I'd encourage you to just go there and ask that same question. Okay, well, so that is the right group of people, right? Certainly, one of the big motivations behind starting Blink as a project to begin with was to be able to kind of decouple and fix a lot of things, do cleanup and all the rest. There's ongoing projects. Just today, I was reading a new proposal for doing a ton of cleanup in a render stack. So, you know, there's initiatives like that. Does that mean that your particular flavor will be fixed tomorrow? I don't know. WebKit has migrated already. Good.
Never heard of it.
Never heard of it. Do they have Service Worker?
No. All right. Well, thanks for all the questions. We want to have a big round of applause for all four speakers. All right, we're going to take a couple pictures, and then we're going to go on to the raffle.
So I want to make sure that we thank everyone properly, by the way, for, this one's mine, fantastic. Guess what I'm doing tonight? So I want to make sure that we thank the speakers properly and thank all of you here for being here tonight. So I think we should go for one more round of our Perf Matters to Me song. What do you think? Yeah. You think we can do that?
Do it.
All right. Come on, speakers. You skipped out on the last one. Get up here this time.
Yeah.
AV crew, can we get some of the AV crew here? Singing while drinking.
Singing this again is not a good way to.
Now,
hands on deck.
Everyone here is going to sing too again, right? Yeah. Oh, come on. It's not too late. You start drinking at midnight. Yar! 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 All right, here we go, you lily lover Bill Drats. I want to hear you all the way back in the mainland. Oh, Perf matters to me. Yo, ho, ho. Perf matters to me. Profile we think. We fix and we test. Perf matters beyond it, yo, ho. We never give up and never will rest. Perf matters beyond it, yo, ho. Yo,
When your users believing and never be glad, drink up me heart, yo. Profile your app and fix it up right. Bananas me heart, yo. Never a sword without a good fight. Bananas me heart, yo. Yo ho ho. Perf matters to me. 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 Drink up me hearts, perf up me hearts, drink up me hearts, perf up me hearts. Perf matters to me.
Thank you, everyone, for tonight. It's been a fantastic event on the live stream. Thank you, everyone. This is a fantastic Perf Like a Pirate Day. We'll see you next year.